So your viruses are safe. Everybody, please grab the blue sheets as you're coming in, or if you've just come in, seek them out and get them signed. We have about 5 seconds till liftoff. Morning.
Good morning. Hi.
Boy, it's been a while since we've seen both of you.
I was, man, you're reading my mind.
Yeah, and it's getting strange, Sarah. I think we can get going here. And I'm not going to hide behind the PC while I'm talking. So, right now I'm in the slides. All right. Well, to demonstrate that we've got this thing working, I'm just going to stand over here. How about that?
Then you're blocking the screen.
No, I'm going to go right over there.
Go to the mic. Gotcha.
Yeah. Let's make sure this is working too. I know this part of it's definitely not working. Let's try this part. There's a red light there, and this sounds good, right? Yeah. All right. So welcome back, my friends. You haven't heard that enough so that you know what the next line is. Welcome back, my friends, to the show that never ends. Ladies and gentlemen, Emerson, Lake and Palmer, brain salad surgery, first cut on side 2. If you haven't heard it, go home and get it. I guess go home and get it means pick up iTunes or Spotify or something like that.
So glad you could have
Right.
Step inside.
There's another ELP thing. So good morning. I'm Al Morton, and
I'm Sarah Banks.
And we are the co-chairs of Benchmarking Methodology Working Group, if you haven't already figured that out. So today we have the clicker working. And I guess I have to point like that. There we go. All right. So at the beginning of our meeting, we always talk about the note well. This is about IPR, which we take very seriously in the IETF. Anything said at the microphones contributed in terms of the email list, and of course internet drafts are subject to the provisions of our IPR disclosure rules, which strongly suggests that folks who have knowledge of IPR please disclose it in a timely fashion. If you're unfamiliar with all these RFCs and all these BCPs and everything else, please leave the room until you've read them, or read them quickly at your chairs. All right. So here's our planned agenda today. First, we have one volunteer for note taker. It's our perennial Marius. Thank you, Marius. I need one backup for Marius because Marius is going to be speaking, and he always complains that he types, and now everyone's deeply staring down at their email. Can I please get a volunteer, a second note taker? Bill Cervini, thank you. I helped you out yesterday, man. So you know, it's like that's how it should work. Thank you, Bill. Jabber Scribe. Anybody on Jabber can watch Jabber? Can anybody get there? Thank you, Joel. You saved us again. I still haven't got this app working, by the way. They're blocking it in our CSO office, I think. So here's our planned agenda. The blue sheets are going around. So if you've walked in recently and you haven't signed a blue sheet, please sign it. The more people that sign, And the more names that are made up, this isn't Chicago yet, but that's the kind of thing that they do in Chicago. It gets us a bigger and better room in the future. So please be sure you've signed, and we'll do that. So here's the planned agenda. You've been looking at it for a few seconds. We're going to cover most of our working group drafts: data center, V6, SDN, vSwitch. One remote presentation at the end of that with Miriam. And it looks like she's there. That's great. So let's see. So then we go on to proposed work with 3 talks in a row by Sudin, a very busy guy. You're going to have to help Sudin out with some reviews, folks. That would be nice. And then, oh yeah, I still have Samuel's name down here, but actually Jacob is going to do the presentation of considerations for benchmarking network virtualization. And then we have 2 essentially sort of invited talks, which I'd like to reserve approximately 30 minutes at the end of our session for. We requested 2 hours. We got 2.5 hours, and that's why I think it's reasonable to kind of do this sort of thing. So they're at the bottom here. Revisiting benchmarking methodology for interconnect devices. Daniel is new to the group, and so welcome, Daniel. And then Masiek, who is not new to the group necessarily, but is working in FDIO and has contributed a quick talk on FDIO and the testing that they're doing there. It's kind of a parallel thing to the vSwitch work in OPNFV. So we got an interesting agenda here today, and I'll ask you now: are there any bashes to the agenda besides the one I mentioned? Okay, great, thanks. So moving on to working group status. Yeah, I think it's almost time for another working group last call on the data center benchmarking. I see the authors nodding, and that's good. So we'll talk about that at some length today. There were some comments on the list, and the drafts were updated right after Buenos Aires. Let's get some good review in that in the second last call. We've got consensus on the considerations on VNF and network function virtualization infrastructure considerations. There were some small updates suggested post working group last call, and that's what I have in my notes here. We need to be sure we cover automation, scalability. I think we've actually got, I've got these written down, Sarah, but noisy neighbors or isolation, I think we've got that point covered, but it may need a little emphasis. And then kind of an homage to Scott Bradner is the way, sort of in his last couple of meetings, he started to stress this wording, which is single factor variation in test iterations. So if you're changing one thing, then you understand how that variable has affected the test. If you're changing 2 things, that's a case where you've confounded some aspects, and you may not be learning what you think you're learning. So single factor variation in our test designs, let's try to keep track of that. It's incredibly more difficult in the world of virtualized testing, and that's why I bring it up. I also learned a few things, these are not comments I got. DPDK removes some security confinement in order to get it. So that's a security consideration. We just have to have a general pumping up of security considerations to do this. And yes, so that's what I said. So those are the additional comments on that draft. I don't plan to go into it any further, but I think I need to spin that one more time, and we should have another working group last call on that, Sarah. I think that's the fair thing to do. Okay. Rather than ignore these points. So, so we adopted the VSPerf vSwitch benchmarking draft from OPNFV. That's a summary of their work up through the Brahmaputra release, and that's good. We're going to hear more about that today. The working group needs to review the current working group items on SDN controller and IPv6 transition. And we've got a stronger connection to open source work than we've ever had now. Basically, the SDN controller folks have connected with OPNFV. Bhuvan has been attending our controller perf meetings, and obviously the vSwitch benchmarking is an OPNFV project. That's open source, and of course we're going to hear today about FDIO. So another connection. Good. This is all very positive. The more connections the traditional specification world and running code world have with open source world is a good thing. New proposals keep coming, so let me get out of the way, and we will hear about some of them. And one new RFC, which finally got completely approved on BGP convergence. Congratulations to the authors. Congratulations to Sarah for shepherding that through. No charter update, and I still need to rebuild my page on the wiki. You know, I actually had a question about that, Joel. How you create a new page in the ops wiki, or
if you don't, you might have edit rights, but not creation rights, and if that's the case,
ask you.
That's yeah.
Yeah. All right. All right. So let's work on that in a hallway time at some point. But thanks. So here's our charter. A few items that are in the red, and a few items which are still coming. And I think we have to add a few charter items here for things that we've recently adopted in the last, one of which is the OPNFV vSwitch. And so that's the one item we need to talk about adding. All right. And security paragraph, it's in the slides. If you're writing a draft for here, this is the paragraph you use to keep the security reviewers from going nuts when they see all this traffic that's being launched into the internet, right? And here's our work proposal summary, which let's see here. I blasted a couple of items off here because they had kind of died through lack of participation and interest. If they come back, we'll remember that. But in any case, so high availability, we're going to hear about that in Seoul. It was a proposal from Korea Telecom, and I expect to hear from them at some point before that. But we did confirm with the authors. They had planned to come to Berlin. They are definitely going to come to Seoul. So you can see that everything else here is roughly at the same stage. We've got a proposal for it. It all looks like it's in the scope of the charter. It's all in the draft stage, but we haven't seen significant support at meetings or on the list, and I don't see any dependencies necessarily. So, so I'll get off of that one. All right, I don't think I updated this one. Any questions about that? The work proposal summary? Okay. So I think that's it. Let's go back to the let's go back to the agenda. All right. So we're going to hear all the working group items first, and then we'll get to the new proposals and the really new proposals, and then the other stuff, our invited talks. Okay. So I'll put this here. And today there's no pink box. Don't be confused walking around trying to find it. Just stand somewhere near this pole. So Jacob, let me get your slides up, and in the meantime, you can start to get comfortable with all these tools. All right. So let's see here. That's not it. And that's not it. See, I had all these nicely layered, and then the small screen thing happened, and yeah. Okay.
All right, great. So my name is Jacob Rapp, and Lucian Abramoff is my co-author here on the data center benchmarking drafts. So we've been working on these for a while. I think we're on 8th and 6th or something revisions of the drafts. So we're, I think, well on our way here. For those not familiar or haven't read the drafts yet, please do so. Or I think we did a first last call, and hopefully we'll do a second one so we can kind of get this moving forward. But for those that aren't familiar, we kind of broke it up into two separate drafts. One around the terminology, going through kind of redefining what latency means. So when you benchmark a switch, for example, in the data center, you had traditionally been just doing first in, first out. But I think that you lose some granularity there. So we wanted to kind of clear up some terminology around latency, jitter as well. Jitter is loosely defined by everybody, then means kind of something different for everyone. So we wanted to kind of come up with a crisp definition of jitter and what that means. Take into account physical layer calibration, what is line rate, add what buffering means. I think there's a lot of discussion around buffering now and what that means within the data center. And I think there's a lot of kind of funny math that's being used. So we try to create consistency around buffering. And then finally, the application throughput or goodput or of the actual traffic. So looking at like TCP and how we actually measure the goodput across the data center. So then we went into the methodology of actually how we test that. So how we test line rate, a whole slew of buffering tests, because not all buffer is created equal, and if just because you have a really large buffer doesn't mean you have a good buffer. And then going into microbursts as well, that kind of gets into the buffering as well. Some of the rates of bursts and lengths will cause buffers to react differently. Different head of line blocking tests move it from kind of small to larger scale, because there's lots of tricks that the vendors can do to kind of get around head of line blocking issues by grouping things differently. So wanted to make sure that was covered. And then look at mix of stateful and stateless traffic. So going back to the buffering, if you have really large buffers, some of these like small UDP flows can get trapped behind some of the larger flows, and different buffers handle that in various different ways. We wanted to cover some of those use cases.
You got the clicker, man. Oh,
Yep.
you did. Okay.
Got it.
Oh, incidentally, if you click back for a moment, I think we're actually on 5.
Is it 5?
Yeah. It's
Oh, no, that's 6.
yeah.
Okay.
Yeah. So
Okay.
so at least in one place it was right. That's fine.
Okay.
Cool.
Got it. Yeah. Okay. Yeah, you're right. Okay. So what did we change? And I like how the format you used last time, where you just put up the side-by-sides of what has actually changed as we've gone through the draft. So change number 1, we added more discussion around cut through versus store and forward switches, and a little bit behind the background behind why we're the differences between a cut through or a forward switch. Just some little added language in there to make sure that it's clear what we're talking about. Next up is the note around goodput definition. So Al, you brought up a good point on one of the security drafts that was out there that actually had a good definition of goodput, but minus the bits lost wording.
Right.
So we took that out and then added that wording into this.
And it appears the original authors of that definition agreed enough that we could take that wording out. I mean, it was kind of a mistake, because the idea is that you're really trying to remove duplicate.
Yes, exactly. Yeah.
Information. If bits are lost, that shows up elsewhere.
Yeah, exactly. Because you retransmit. So yeah, exactly.
Yeah. So good. I'm glad you got that covered.
Change number 3, again, big thanks to Al and Scott, who helped a lot on the on editing, or not editing, but like helping with the discussion and keeping this draft moving. So
yeah.
I just added that thank you to you guys.
Who's this guy, Alfred?
Yeah, I know, exactly. So I mean, that's it, right? Currently last call, as a little homage to Scott, it looks good to me.
Right. Right.
I think we're pretty well.
So I guess a point that I don't think you've mentioned in a while is that you guys have actually used these tests
Yes.
in a lot of data center applications already, right? And they've been basically found to be useful, and that's the kind of thing that drove this
Exactly.
draft to creation and to near completion here now. So I guess it would be good if we could somehow capture that maybe just in list traffic during the second working group last call, so that we could talk about, where other folks have seen this work come to be useful. And
Yeah, absolutely. I think there's several vendors out there that are actually using some of basically from this methodology. So
Cool.
I think
cool.
I can put it on the list. And
Yeah, let's try to get some evidence of that, so that it's of lasting value, and folks should, this is an interesting area. Folks should take a look at this during working group last call if you haven't yet. By the way, who has read this draft in the room? I see 4 or 5 hands. Okay, good. All right. So okay, Ramki's got a comment. Yeah, I'm glad you got up, Ramki. Opening the floor for comments.
Thank you. Ramki Krishnan, Dell. So just a thought is that just carrying on Al's thoughts on where this is being used, perhaps we could add some applications, like say, hey, big data for buffering or whatever it is. The appendix.
That's exactly a good use case that I was thinking of. There's been several papers put out on big data and actually looking at buffers and stateless versus stateful traffic and how to deal with, because if you look at like some of the big data applications, there's a mixture of like very high speed traffic and then big long like pushes and mixes of east-west traffic. So like HBase is like an example where you have like some latency sensitive things, and then it wakes up and then does a whole bunch of like traffic east-west that actually causes some real issues that we presented at a Hadoop conference a while back, and that showed the value of this.
Great, and maybe it could even go in the appendix as like
Yeah, a good point. Yeah.
Perfect. Thank you.
Thanks.
This is Mario Georgescu again. About repeatability, I keep talking about the same things. I think it's the number of iterations. You guys say, okay, it should be repeated a couple of times, but there's no, I would say at least the lower bound, like a minimum of, like Scott said in 2544, 20, or like a number like that you think is relevant for the repetition. So like, for example, for the last test, how many iterations did you do for jitter, for example?
So instead of just you should be doing multiple iterations, like you should do 20 iterations or 5 iterations.
So that gives you a good
Just
variation, right? And also you say about variation and you say percentage. Do you mean like plus minus 5% of the average, or what exactly do you mean? Because I'm not sure. That's what I understand right now from the wording, but I wanted to ask you.
For the delay variation?
Or
which
section? For like in the reporting format, you say percentage of variation, and then in brackets you say minimum max average. So I'm assuming that it's like it's percentage of the average for minimum and max, like plus minus 5% of the average, right? That's the variation.
Yeah, because it's exactly. It's like the variation. The percentage,
Maybe that should be clarified. So this is like very shallow stuff, and I think
good point.
It's easily covered. Okay, that's it from me. Thank you.
All
right. Stephen Wright, AT&T. So a comment on your section 6.3 on reporting format. So I think you're assuming the reports are human readable. And it occurs to me that one of the major uses for this stuff is going to be looking forward to more automation. So if you get a benchmark that comes as metadata with a thing that an operator requires, whether that's a VNF or some piece of infrastructure, it's going to need to be packaged as part of the metadata for that thing. So you're going to need that sort of format, and you'll have the same kind of thing in the operator. When you run the tests, you'll get some result, and you'll want to be able to bang the two together mechanically and see whether it matches, right? So you probably want to have some words in here about that sort of machine readable formats of the test results as a maybe a direction for future work. I wouldn't suggest trying to solve the whole problem.
Yeah, I don't know. Yeah, I mean, I think it's a good point, but I don't know how we've done in the past on like different drafts of like how the formatting should be done. But
Well,
It's-
in the past, the past is the past.
Yeah.
And the best way to introduce us to this new world is forget the past,
Sure.
embrace who we are.
Yeah.
And right now we're in a world where automated testing is incredibly valuable.
Oh, yeah.
In fact, with all the variables we have to examine, automated testing is the only way to go.
Yeah.
And I just mentioned that that's got to be part of the considerations. So I completely agree with you, Steve. Sort of a machine parsable format, in addition to the human readable stuff, should be something general that we provide now.
Well, maybe something like for the broader group to kind of discuss for like, as here's a common report. It's just like we have like the security considerations in the section of here's a security considerations. There should be a formatting considerations for drafts. I don't know if necessarily we should put it in this draft, but have that as like a separate piece that we can start adding to every draft, I think, at that point, right?
So I think it comes back to what did you intend when you wrote the draft? And having started my draft at the same time you guys started your draft,
Yeah.
I got the distinct impression that you were expecting folks would sit down with like an Ixio or an Agilent or some test gear and some person is executing the tests, which
Yeah.
I think ultimately comes back to, how do we don't typically specify the format for that other than on a per draft basis.
Mhm.
But I think Stephen's point around automation dirties the waters in the sense that coming at that is an approach that I'm not entirely sure the draft specifically takes into account today. And I would argue I'm not entirely sure it has to either, other than that you give it some thought. And if it lends itself well to it, great. But I didn't want you to also feel beholden to it since I didn't get the impression that that's how you were coming at it from a writing perspective.
Yeah, I think what I'm asking for can be solved by a couple of sentences in the section about further consideration may need to be given to machine readable formats for reports to support automation or something like that.
Yeah.
You don't have to solve the whole thing in this draft.
Yeah,
It's
exactly. I don't want to
Yeah.
open up a whole can of worms of like, I want to solve the formatting issue in this
Right.
draft.
3 more years.
Yeah, exactly. So,
That's right.
Sure.
And it's not, I mean, in one case that I'm thinking about generally over the working group as a whole, but in the specific case of SDN controllers, I mean, these things are going to be packaged for download, and if you package these results that have been measured in some form, along with the collateral information that comes with the controller, that's not a bad thing.
No, agreed. We saw this so I don't know if I'm stealing Ronke's thunder, but we saw this in NFVRG as well. People were asking for, well, what and how did you test? I
Yeah.
did not go to the mic, but I wanted to. But it's agreed. It's the same idea. But I think Stephen's point around, it's just a future considerations, and then we may or may not rev the draft or do a biz draft or a related draft where you could come at it from an automation perspective.
sure.
It could be useful, but it would put the pin in this one and let you
Yeah.
come at it differently in the next.
Okay.
Just an opinion.
Okay, Marius Georgescu, I wanted to maybe add that I guess this could be relevant for my draft as well, and it definitely is an interesting proposal. But like I was thinking, everything that is reported for my draft, at least, it's supposed to be read by a human, not by a machine. But then again, we could note something like that, and just like if we forget the past, we might repeat the errors. Just like
Right.
we shouldn't completely forget it. Maybe some parts.
All right. Thanks.
So, just want to carry on the comments. Essentially, I think the automation, especially considering DevOps, is a great idea. And in the NFV landscape, I think really it'll work very well, because already, as we can see, if you go to OpenStack, what really happens is you have a pre-boot, scenario where essentially you're looking at the benchmarking results and even making decisions on placement, right? I mean, bringing the right images, etc. So I think it'll be invaluable to continue the discussion on this list, and perhaps a joint one with NFVRG and how to shape this forward. And perhaps maybe it could be valuable to point this out in your draft too. I mean,
That's what I'm thinking. Yeah.
All right, great. Thank you.
Thank you both for starting this in the first place. It was a long time ago, wasn't it? Okay. All right, so IPv6 transition is next. And what the heck? Oh, I know where that one is. That's this one. All right.
Control F5.
Control F5.
Yeah, that should do it.
Seems not. Let's try.
View and then full screen.
Yeah, that
Full screen. Or Control L.
Control L. All right. Now we're talking. Now, can you advance that with PDF? Did you get the tool? Here's the tool. Yeah, it works. Okay.
Okay, good morning, everyone. My name is Marius Georgescu. I'm from Nara Institute of Science and Technology, and I'm going to talk about a drop dedicated to IPv6 transition technologies. Yeah, essentially, I guess most of the people here know about IPv6 and its big problem. It's not really backwards compatible, and yeah, it keeps increasing. It started increasing exponentially. The worldwide number for users that have IPv6 connectivity now it's at 6%, but it's still pretty low. Also, we have plenty of IPv6 transition technologies. It's some of them are hard to grasp, some of them are hard to understand, and essentially this great diversity will raise some of the questions for like how do you, like for dual stack, it's easy. You can use RFC 2544 or RFC 5180, and you can use them separately to test either IPv4 or IPv6, but how about encapsulation or translation? That's what we're trying to do with this draft. So also, given the diversity I just showed in the previous slide, we came up with a way to generically classify some of these transition technologies according to the technology used for the core domain. And we came up with 4 groups. We have dual stack, single translation, double translation, and encapsulation. We also made a table to show how most of or some of the transition technologies actually fall in these categories, and we think it's exhaustive. We asked for some more feedback from V6 Ops members. Yeah, from the discussions I had, at least they seem to be exhaustive. Now, yeah, this is the overview. I'm just going to skip thread. In terms of the update, so we had a comment last meeting from Tim Chan about having some mixed traffic conditions, and we actually added that. Also, there was a discussion about having NAT 4.4 and NAT 6.6. This started actually with a comment from Fred Baker in IETF 94, and we asked at that time, is it worth mentioning? Should we? Because NAT is more a coexistence technology, is not really a transition technology, so it doesn't really push the transition. But yeah, since we can reuse some of the benchmarks for NAT as well, we added a section there for that specifically. And yeah, we had a comment from Jacob about why not, like if you're testing, if you're doing 500, you're taking 500 samples, why not just show the histograms as well? So show the distribution, not just the summarized result. And yeah, it makes sense. We added a May for that. We also didn't get any support for DNS 4.6. Nobody in DNS Ops as well as Bmwg, nobody said anything about it. Well, there wasn't even an RFC for that, so it's kind of clear that it's not going to be a standardized transition method. So, and also, we have some various smaller editorial changes. Yeah, so this is the text we added for having mixed traffic conditions, and it was basically inspired by RFC 5180 because they had something similar. The biggest difference is maybe the fact that we have to have IPVX only traffic, which may mean IPv4 or IPv6, depending on what transition technology you're using. And then we have various percentages of that, so you can test with 90% IPv4 traffic and 10% IPv6 traffic and so on. This is for the mixed traffic. Now for NAT 4.4, NAT 6.6, we added, single translation essentially applies. The single translation test setup and benchmarks apply for NAT 4.4 and NAT 6.6. It was quite simple to solve this one. For fine grains, for a fine grain analysis, use the histogram. So actually, I'll ask the people that comment on that if they're satisfied with the text we added specifically for that. Also in I wanted to stress about DNS 6.4. Yeah, again, no support for DNS 4.6, and yeah, we're not going to include it in the draft. If you have time, please give DNS 6.4 perf, like it's an open source implementation that Daniel Bakay from Gabor's team, from Professor Lenche team in Hungary developed, and it's in compliance with what we wrote in the draft. So if you have time and you're interested, please try it. Yeah, the most important part, the next step. So we had a discussion like that was Jacob's point as well, and maybe we can discuss some more on that. So he was saying, like, where exactly do you want to add? We said we're gonna test, or we're gonna identify 500 frames in a flow. So how you're gonna have to add a tag there. So how do you add that tag, or where exactly in the frame you would like to add it? We haven't had time to test that, but from what I tested before, like one of the traffic generators I used, the ITG, it's implementing that as some sort of UDP sequence number. So there's some sort of identifier in the payload. That's what we were thinking as well, and we're trying to come up with, we called it, or I don't know, this is it's a draft name, 6trans perf, something like that. That's what we're kind of trying to do, that considers overhead of encapsulation, translation, has some options for that. And yeah, it's in conformance with the draft. That's what we're trying to do, and that's what we're planning. If you have other suggestions, please tell us, and we'll try to work it into the implementation. And yeah, we're 2 questions. Okay, we have a comment from Jacob.
Yeah, so yeah, I think it's good to have a kind of a concise piece where you say, okay, use this for it. But I think you still, is it open to kind of, okay, what if I put the tag at the very end of the packet? Because that's one of my points of like when we do the measurement for latency, right? If you just put something at the very beginning, you don't know if something happened. You mean have some padding before in the payload, before the tag essentially, or like just at the beginning of the? Yeah, I guess. I mean, I guess the tag is going to have to go. It's not. I mean, could you put it in the payload? Right? Probably not, right? So I think this is probably the best route to go. But I'm just saying, like, can you miss something? Yeah, that's why we really haven't tested this thoroughly. So we'll see, and if we have any, well, I don't know, like any problems with that, we'll contact you and we'll keep discussing. So I'm not sure I get your point. Why wouldn't you be able to put a tag in the payload? You could. Yeah. So yeah. Like I understand the point of having it at the very beginning of at the very end, but then again, I don't really know if that's going to affect too much. Yeah, but we'll test and we'll let you know, and we'll progress this somehow. Yeah, thank you. Okay, and also, so yeah, the comments covered well enough. I don't know, Al, you had a comment. I added the reference to the, I think that was one of your comments, the reference to percentile, because it wasn't like median and percentile they weren't clearly defined as like, well, and there were three converging definitions that
actually mutually exclusive definitions of how to calculate percentile.
Yeah, okay. So yeah, I added the reference for that, and that should make it clear that we're using just one. And yeah, again, after we covered this comment as well and then improve some more the draft, we were thinking IETF 97 first working group last call. What do you guys think? Yeah.
Well, let's first ask.
Let's
read the draft. Some hands. Okay, that's good. Any comments today? More comments? So I think in the grand scheme of things, it feels like we should have a working group class call on this between now and IETF 97, right? So sure. So let's plan on that, and we'll phase it with the others. I mean, I think we definitely want one on. It's really a second working group last call on data center benchmarking, and also on the considerations for the which we thought we were done with, on DNF and NFVI infrastructure. So we should probably have those two first, and then we'll phase this and maybe another one.
Sure, we feel there's still improvement, and also I want to confirm with Fred Baker. He had he had many comments about the incremental scalability versus simultaneous scalability. So I want to make sure that he's okay with that as well. I haven't got an answer yet, but yeah, we'll look to that.
Okay.
Yeah, that's about it. Thank
Very
you.
good. No other
Okay.
comments? Okay. Marius, thanks a lot.
Thank you.
Don't forget to give that back. All right, Sarah, I think you're up.
Sweet. I know. I'm not going to stand.
Okay. Let me get your slides up first. Though.
Thank you. My slides are colorful. My co-author did the slides. Bless his soul. I like the little shout out to Kesha in the slides. That's great. All right, so benchmarking SDN controller performance. I don't think the objective has changed since the last time we were in. I think if anything, it's getting more traction, particularly even outside of IETF, with Bhuvan attending OPNFV, for example. The idea here is to benchmark performance, scalability, reliability, and security of the SDN controller, that is the device under test here. We're looking to define metrics and a methodology to assess and evaluate SDN controllers and provide a standard mechanism to measure and compare the performance of different SDN controllers side by side, apples to apples. So history, I won't bore you with the history. There's a long, not as illustrious history as the data center guy sitting in front of me, so I'll skip this slide. Some changes to revision 6. We had some wonderful comments from my illustrious co-chair here, Al. So let's get into those. Thanks to everybody who's been reading and sending. I would urge, though, everybody to put the comments on the list. We're still getting unicast quite a bit.
Yeah, we really need the evidence of the commentary when we consider whether a draft's ready, and so that's the way to do it. Comments on the list, please.
Yep. So in the terminology document, there were, I don't know why it says 4. Oh, I see, in terms of the 4 different metrics that were updated with Al's comments that are listed here. And then in the methodology document, we reflected the changes for the test metrics definition that were made from the terminology document into the methodology document, of course. So I think the comment you made, Al, around asynchronous message is something that we still need to address. We didn't get to it in time, unfortunately. And then the processing rate. And then from the current methodology, we're measuring the response rate with and without packet loss. And then the proposed methodology is to instead measure the response rate without any packet loss, kind of like the RFC 2544 throughput test. Right? We're very careful, or trying to be very careful to not be conformance testing, as Scott would say.
So let me just add to that. Our comparable drafts here are sort of the way they're doing these asynchronous packet in to flow mod out response tests are kind of like our maximum frame rate tests in 2889, where you're allowed to lose some packets. You basically just you pump packets at the device and you find out, measuring at the egress, how many packets got through. It's more like that kind of test that they're conducting now. And so what I'm suggesting is that we back up and pick up the lossless case. So what rate can you handle when there's no loss or extended latency of these packet in to flow mod out pairs? And I think that's going to be more like the normal mode of operation that people are going to want to use with these controllers. And so it's a distinct difference. It requires a little different tooling. The classic tools like Cbench, it's going to be a little more difficult to measure this, and so that's where the challenge is to the new vendors in this space.
So we've been having a lot of discussion internally about this too, where I think one of the points that I proposed is that we continue coming at it as if you're pumping in too much traffic and dropping packets. But once you see what you're pumping and what you're dropping, maybe that gives you an idea of what you actually can handle. And then you can back up and have a starting point with some sanity to the test case you're explicitly calling out, which is, okay, well, how much traffic can I push through without dropping? Because I think a lot of folks agree, they want to know the answer to that. And so for me, it was sort of buried in there. And my take on your comment was that it was calling that explicitly out. And I think that's valid and we need to address.
Good.
We just haven't 100% agreed on how to do that.
Yeah, it's definitely tricky to keep track of these packet into responses, because they may not be unique and yet they may be sufficient if they're not unique.
Yep, agreed. All right, so next steps. I'll one up Al and say, who's read the draft? Okay.
Good, about 5 or 6.
Okay.
Oh, good, comments.
Sweet.
This is Marius. I think you mean working group last call. It says ISG review.
Yes, I did not see the slides before I sent them over to Al. My apologies.
No problem. It's yeah. I guess yeah.
That's what he meant. Yes. I think we'll do comments before we get to that, though. Yes, Stephen.
So I was a little confused in the methodology document about the security and reliability tests, because they're pointing back to the test set up in section 3.2, which has data flowing through the data path.
Yep.
So I'm not sure how I would expect to see tests from north-south through the controller. So I would expect different test points or a different test setup. So
Yeah, so I too saw after we submitted the draft, that went in before I had a chance to take a look at it too, and we had made major changes from the previous version. So I think that was a mistake to point back to 3.2. So in the next version, I think we'll address this.
Another test setup figure that.
It needs to be, I think. Yeah.
Yeah. Okay.
Thank you. Any other questions? Oh, sorry.
No, I was going to say the same thing. Seems not. Oh, maybe, yes.
So they're still not.
Say your name.
Yeah, sorry, Marius Georgescu. I still haven't seen, or there was the discussion last time about the summarizing function. Is that still something that's being discussed among the co-authors, or is it still considered?
What do you mean the summarizing function?
Like, is it median? Is it average? Is it and the variation as well?
So
I think-
summarizing statistic.
Yeah, like
Yeah,
statistical function.
We will take that and discuss. We had talked about it probably 6 months ago at this point, and I thought that had been clarified. So I'll go back through with a clean eye and look at that again. And if it's not, I don't believe there was discord around what it should be. So I think at this point, we probably, based on your comment, might need to explicitly state that in the draft. So I'll
Okay.
take that note and we'll go back and take a look at that.
Okay, sure, thank you.
Thank you.
Okay. So this is a hot topic, and in the industry, obviously, and there's even some new work on hoping to change the southbound interface, or what seems to be the sort of the, what's the word I'm looking for? The de facto standard for the southbound today is OpenFlow. But there's new research in this area, P4 and then some other things that might be relevant. So one of the things that we tried to do with this draft was to make it more generic. And it would be interesting to find out too if some of our generic metrics are applicable to other southbound interfaces beyond OpenFlow. I mean, OpenFlow was clearly the model, but that's the question I have in my mind now that might be a worthwhile thing to investigate. So that's an Al comment, participant. And, you know, and if we find it's not, you know, that's probably okay. It just results in limitation on the scope. But, you know, let's answer that question before somebody else asks us. Ramki.
Ramki Krishnan Dell. So one of the things we're seeing from the technology front is, for example, the same vSwitch function is being implemented in intelligent NICs, right? So perhaps it's worth making some mention of it because this is software, but there are several ways of implementing. One is it could be an ASIC-based implementation, or it could be an FPGA, or there are some implementations using actually P4 to do that. But what is also interesting in that front is the management interfaces are all preserved, you know, OpenFlow, whatever it is, OVSDB. But the only changing element is the actual implementation software, you know, in a general purpose CPU versus, you know, some other methodology like an FPGA ASIC or a network processor. So I don't know how it falls this under scope, but I'm thinking more like worth mentioning here, because here there's a software implementation on a GPP, general purpose processor, which definitely will have different consideration, but there could still be some commonality here in certain aspects.
So would clearly listing what the physical-ish, with including the software topology, is as part of the test case for the benchmark, do you think that would suffice?
That plus I was also thinking maybe worth making references to other types of implementations. I can actually send them on the list. In fact, it's pretty public. Mellanox has an intelligent NIC which does that. So, also the question is whether we want to spend time on identifying the common areas versus what is different. It's a question we need to consider.
All right, let me think about that and talk to Bhuvan, and we'll come back. But in the meantime, yeah, if we can take it to the list, and if you want to share your sources, that certainly helps.
Sure. Thank you.
Thank you.
Thanks. Good. A lot of good feedback today.
Yeah.
All right. So, unless I'm mistaken, next on the agenda is Miriam Tahan. I'm talking in the wrong. Talking to my bottle here, not the microphone. The next on the agenda is Miriam Tahan on the vSwitch performance from OPNFV. So let me try to get those slides up. And Miriam, you can start talking to test this out anytime here, I think.
Good morning, everybody. Can you hear me?
Yes, we can. It's a little bit distorted. If you can get close to your mic, that might help.
Is it better now?
Give us a short count there, Miriam, up to 5.
1, 2, 3, 4, 5.
It was real clear at the beginning. So wherever you were positioned at that point, that was good. I think we can all hear you pretty well. And folks here, okay? All right, very good. And
Okay, hi folks. My name is Miriam Tahan. I'm a network software engineer at Intel, and today I'm going to be talking about a draft that is relevant to informing about the work that we did to OpenFV around benchmarking virtual switches.
Miriam, excuse me a second. Hang on. It sounds like there's a lot of background noise there.
Not sure.
Is it echo?
Let me see if I can do anything here.
Speakers while talking.
Miriam, you might mute your own speakers while talking, unless you're on a headset there.
I am on a headset. I apologize. Sorry, folks. If I move my laptop now, I was actually going to disconnect. It's in a docking station to move location. Is it any better now?
It's a little better, yeah. I think we can still hear a little background there, but it did seem better. Please go ahead. We'll give it a try for a while.
Okay, Cool. So this draft, I've co-authored this draft with Al Morton and Billy O'Mahony, and today we're just going to go through the updates from since the last IETF meeting. Essentially, the draft was adopted as working group item. So thank you, folks, very much for reading it and reviewing it and voting. And since it was actually adopted as a working group item, new discussion has actually popped up on the mailing list from Sudine. Actually, a couple of questions popped up, and Joel and Al and myself have been working on tackling those. So let's have a look through what these discussion items are and what our approach would be to resolve them. So Sudine suggested maybe looking at benchmarking the address learning rate of the virtual switch in the case where where you kind of exercise the table limit, where you force the virtual switch to learn as many max as possible for it to learn, then take the time to learn that number of MAC addresses in steady state, clear the MAC table and measure the time to relearn the same number of MAC addresses. Our work in OPNFV actually has address caching capacity and address learning rate tests, but it doesn't include this clear and relearning test that was suggested by Sabine. And the other thing that was suggested to measure as well was the recovery time for the virtual switch. In what was described as negative scenarios. I believe Joel clarified and simply stated that these seemed like they were more like scenarios rather than negative scenarios, and I would tend to agree with that opinion also. But maybe that's an item that's open for discussion with the group here. And actually, Al made a very interesting note about the recovery times might not be very interesting for the virtual functions, because many operations have to happen in the case of a reboot, and in some cases they may involve manual operation. I don't know if I'm 100% with you on that one, Al. I think from a service assurance perspective, in certain cases, it would be definitely interesting to know the vSwitch restart time, if you can measure something like that, or recovery time, if you can measure something like that. But again, that's something that's open for discussion. And in terms of whether or not these comments should be resolved, our suggestion is to take them as input for further VS-Perf tests in the next release cycle, implement them, test them out, and see what comes back.
But only to note them in the draft here, because we've decided to freeze the summary on the Brahmaputra release.
Exactly.
So yeah. Yeah, good. So, oh yes, please go ahead, Miriam. Sorry.
No, that's it. So just the last slide is just a kind of a quick summary of what's going on. Basically, the working group adoption was successful, so thank you again, folks. Is there any further comments regarding the draft, if anybody has read it?
So Ramki's coming to the microphone here.
So Ramki Krishnan Dell. So one of the interesting challenges I see here is the feature set which you're benchmarking with. For example, in vSwitch, especially when it comes to OVS, it's kind of a little bit of a moving target. For example, recently a rate limit for VLAN was introduced, and potentially then rate limit based on ACL come up, right? So I was wondering how best to capture all this. Are we going to say that, hey, this is the scope of the draft, I'm going to limit with this particular version of the vSwitch, or are we saying, thinking about a different approach, something to think about? And also on a similar lines, even in the vSwitch, there are several implementations. One is in the kernel, and there's also, as you know, the DPDK based vSwitch, right? How do you capture that access to? Again, is it more of a freeze approach and say, this is the scope of the draft, and say, this is it? Or any other strategies? So something to think about.
Okay. Our strategy so far has been not to focus on particular revisions or versions of virtual switches that are available out there. It's actually been to write the draft or the test cases with the view of being virtual switch agnostic. So we know, virtual switches can do X, Y, Z, or will do X, Y, Z, and we plan the test cases around that, rather than saying, I'm going to use OBS 2.5 with X functionality. It ties you down to one particular implementation too closely, whereby the aim, which kind of disagrees with the aim of BSPerf, which is really to be virtual switch agnostic. Our framework is implemented in that way, so you can plug in a number of different implementations under the hood and benchmark them using the same test cases.
Wouldn't that give you more, as the tester, I think the onus is on us to take the same methodology and apply it to the different implementations, so to speak, rather than have a methodology that is implementation specific, so that with a common implementation, you can then take a look at comparing the different variations and seeing which one works for you. I think we had I forget who the heck it was, but somebody in NFERG had done sort of the same thing and presented the output, and it was really well received. And in my mind, this is the same approach that Miriam's proposing here. Do you see what I mean? Like, would that not work?
So the challenge is, I think, two directions. Right? One is, even if you consider a common something not very specific, implementation specific, say DPDK based or a kernel based, overall itself the feature set is moving in a certain direction, in the sense there are new features being added. So the question is, how are you going to capture that? And also the latter one, though there is commonality between a normal V switch or DPDK switch, there are some subtle differences. The question is, how do we capture those? Or we say this is not the scope. We just do the base feature set and say this is the scope and we done with it. That's another approach.
So since I see your point, and I certainly have sympathy for that, and there aren't going to be 15 different DPDK implementations considering who it comes from, but I think you could also potentially submit an example of what you're thinking about Romkey, and then if it has the value that I suspect it might, the authors could consider adding that to like an appendix as a discussion point,
Sure.
for example.
Yeah. I'm also working with saying that, hey, this is a base feature set, and this is kind of this is a snapshot, and that's also, I'm also fine with that. Yeah. Just wanted to make sure that we are aware of all the other happenings. That's all. Yeah.
Sure.
Let's hear what Miriam thinks.
Yeah, I mean, it sounds really good. If you can send on what you have in mind, we can definitely take it into consideration and see what we can do there.
Thank you.
I'd like to point out I was also quoting another chair who did the exact same thing in his working group earlier this week. Thank you, Romkey.
So let's get some just for clarification and a good discussion there. Let's get some comments on the list so that we have clear action on the draft going forward.
Yes.
This is Carsten Rossner for ENTC. I have two questions. The first one is about this duration for the pre-qualification of this reference VNF mentioned in the document. It says test at least for 72 hours. And I know it's only for a very specific case, and it's not in the body of the test methodology, but it sets from my point of view, dangerous, special case precedents, because we see ever increasing requirements like 24-hour burn-in test, 72-hour, and I don't see a basis for this requirement, and it makes testing virtually impossible if you want to go to scale and automation.
So let's let Miriam has covered this actually before, I think in the first or second time this presentation came in. So why don't we let Miriam deal with it's okay, that's fine. But why don't, since you have two questions, let's let Miriam answer the first one first, and then we'll go to the second.
So regarding the 72-hour testing, it's actually been feedback from many of our customers. I know the actual test that you're describing is the SOAK type test, and it's just a prolonged variation of one of the base tests that we actually do. Why we selected 72, again, it's been feedback from our customers as to that's what they actually do in the field before, well, in their labs before deploying to the field. And that's where that heuristic came from. I mean, sure, I mean, it can be reduced to 24 hours. We can make the wording seem a little bit more loose around it. But I still think it's worth doing that type of testing if that's the actual testing that happens in our customer labs.
So I think, excuse me, sorry for being open, but I think customer feedback is irrelevant. What's relevant here is mathematical, statistical relevance, and that would need to be calculated. And I think, you know, in this industry, we often are happy with a confidence interval of like 95% or something, where we run reliability, resilience, failover tests only 3 times, which is, you know, wildly off the mark of actually getting to something that's statistically relevant. At the same time, we say like we send like 1 trillion packets for over 72 hours, and we get a confidence interval of 99.9999% probably. So I think this would need to be justified more clearly. So for us as an independent test lab, it's a big issue to tell our customers, like, if we run this test, how confident can you be that the results of the test are actually representative of the actual underlying, you know, performance? What is the mathematical model? And as long as we don't calculate that, I'm not volunteering to do that. I'm not a mathematician, but I think that would need to be done if we say like 72 hours is an important milestone. Otherwise, we would need to say, well, we run each test 100 times just to be on the safe side.
So I think you mentioned 2 different points. So running the tests a number of times versus the duration are 2 separate issues. So let me deal with the duration first. I think in a case where, on one hand, I have sympathy for your perspective. I understand where you're coming from. On the other hand, when we're taking on something as new and as hot as it is to characterize the performance of a vSwitch, because it's brand new, because it's an implementation or implementations we don't understand end to end and have expected performance outputs, it sort of reminds me of the first days of, you know, router testing back when we were first doing them, where you would run them for long periods of time because routers would behave distinctly differently at hour 72 versus it would the first hour. And I think customers are doing this for a lot of those exact same reasons. We don't understand how it works. We want to understand if performance degrades over time. So now we can fight over whether or not it should be 72 hours. And I think that's where Miriam's giving you some leeway. But I don't know that you know, ignoring what a customer or customers want to do, I don't think is going to get you very far in this particular topic, because I think there's sort of widespread agreement that they're going to do it anyways, and probably for pretty valid and prudent reasons.
It's not about ignoring customers, it's about setting a standard. And RC 2544 and others were defined early in the times when router benchmarking was starting. And they don't say 72 hours. They say like 2 minutes or 5 minutes or 10 minutes. For practical reasons. And of course, we are free to run this test for 72 hours or 100 hours or, you know, a year. That's
Correct.
Not the question. The question is, what does the standard require as a minimum? And this draft requires 72 hours as a minimum. That's my only point.
It's one test that
That's
requires.
actually one test. Yeah, sorry, Sarah, you're correct. So
No, please
It's,
go ahead,
it's
Mary.
one test,
yes,
right? But
so we
it's,
do have shorter
the other
tests.
tests are not specified in here.
Sorry,
Yeah,
Miriam?
We do allow shorter durations. In
Yes.
fact, I think if I remember correctly, the range given there is like 6 hours to 72 hours. And I mean, at least that was the way we talked about it in the test spec. As far as what ended up in the summary draft, that might have been slightly different wording. But the point is, I think, you know, in my mind, when this test was already described when I first joined the project in February, more than, you know, a year and a half ago, and I resonated with it because software errors and collisions in software systems are probabilistic. You may have to run all sorts of processes for a long time before you get the confluence of events that causes the kinds of performance problems that you would want to measure in the long term, because they're going to affect your operation in the long term. And that's the kind of thing this is after. So it's not that you have to run every test here for 72 hours. It's certainly not saying that. But checking things in your mode of operation once for one soak test, that's that's perfectly possible here, and that possibility is in the spec.
Okay.
Incidentally, I'm going to cut the lines at Pierre Lynch,
Sure. And I'm
who's 4 deep.
my second question is really a newbie one. Apologies for that. So the core of the document doesn't really describe the actual tests, right? It just references the LTD in the VS Perf thing. So how is this going to work? How can I actually use this if it becomes an RFC? How can I use this document in the end? Because it refers to a moving target.
That's exactly right. It refers to a moving target because this is an open source project, and what we plan to do at a future time when the LTD, and now we're going to split it into 2 things, the LTP and the LTD. When we have those things more stable, then we're going to bring all of that material in and propose that as an RFC. So
Okay, but still the plan is to have an RFC that is referencing something that's ongoing work.
That's right. That's
Okay.
right. It's a summary of ongoing work, in fact. And it was necessary to bring that in so that we could have this connection between our traditional standards waterfall world and the way that open source works.
Okay.
Maybe resolved already. Sorry, Stephen, right? I was just going to comment on the 72-hour thing. I think that there may need to be some improvement in the wording in the section, but the point of soak tests is not to measure a numerical value of throughput. The throughput is just a load to stress the system to make sure it's stable for that period of time. And that's to deal with the collisions and the memory leaks and software maturity issues and that kind of stuff. And if you detect some variation in the throughput, that's just a detection of some other problem. It's not really a measurement of throughput that's trying to be achieved. So maybe some clarification in the wording helps.
That's a good point, Steve. Thanks.
Marge Georgescu, I wanted to +1 the discussion. I think there should be some sort of justification for having 72 or at least 6 hours, even 6 hours. If you think about repeating that test, that's a lot of time. So, like, why is it really needed that much? Like, why not an hour? Or why not 2 hours?
So why don't we take this discussion to the list?
Yeah.
Because I think we could spend the next hour talking about this.
Yeah, sure.
Yeah, agreed.
Pierre Lynch from Mixia. I want to address it as well, though. But the one comment I want to make, the 72-hour test, everybody has been talking about. The goal is you're going to get variations in the throughput. You're going to find a software bug. You'll turn around and fix it. So is the goal of that 72-hour test really benchmarking? It's bug finding. Does it belong in a benchmarking draft is my question. It's not, the goal is not to find the performance, the goal is to find a bug.
Well, you could argue one's hoping one doesn't find a bug and it's proof therein, but is it a valid benchmark? I think, again, your point we should take to the list because I suspect it's also going to generate conversation for an hour, but it's a good one and a variation on Stevens. So would you mind sending it to the, thank you, sir.
Yeah, that'd be great if we could start that discussion on the list. For me, it's as well as a validation of most things everybody said here, it's also a performance stability test, which is important. But again, let's take it to the list and let's trash it out there.
And I'll say, as a final summary, a lot of our tests are measuring the performance of functions that we assume are operating correctly. And as a result, when you get a performance result, you've also got the result of the functional test. It's just that functional tests are beyond our scope. We don't do anything that's pass-fail here. So we really accomplished 2 things. All right. Okay, thanks very much, Miriam.
Thank you, folks. Thank you.
All right. So now I've got to bring up the slides that are not currently queued. And that was a good discussion. So we've reached the point where Sudin is going to entertain us for a while. And so I'm going to bring your slides up as quick as I can here, Sudin. So let's see here. Okay, I think they're all down here. Yeah. No, that's the last one. PM. There we go. All right. Okay. Oh, here's the clicker. Okay.
Is this?
Working pretty well.
Probably want to stand back here.
Yeah.
Yeah, that's good. And then just
Can I take this?
yeah, you can take the mic out. Everybody's doing that.
Okay. Yeah, good morning, everyone. And this is a draft on performance benchmarking, performance monitoring. First, we presented this in Buenos
Better,
Aires.
yeah.
So we got.
Keep it high. Keep it high.
Oh, okay. It's better.
Yeah.
Okay.
Yeah.
So we got a couple of comments on that. We incorporated and we just revised the draft and presented in this meeting. So this is all about. Benchmarking the Y1731 performance monitoring. Normally, why we are doing this? Because this is widely used, and the protocol does not, this Y1731 talks about the protocol, but it doesn't talk about how to benchmark it. People, define their own ways and implement this. But we want to, benchmark this so that it will be beneficial for the community, provider community. So these are the review comments from Al. Like synthetic loss measurement should be added, and sections with cause and without cause. These are the two comments we added that. So this is our topology, and this is a DUT, and traffic generators or the router tester connected at the both ends. So these are the benchmarking parameters, the parameters we defined it. To benchmark this performance monitoring, first is a measurement of the loss, delay, and synthetic packets at various load. The traffic which is flowing. Then the impairment and the failover. That means the routing engine failover and the soak test and the reliability. So 5 parameters we have mentioned, 5 parameters we have defined it to benchmark this particular performance monitoring. So the first one is measuring, synthetic loss measurement, delay measurement, and synthetic loss measurement, delay and loss measurement with various load. That's from 40% of the line rate, 80%, and without traffic. So for a short duration of time, and we measure the performance and we record the values. And impairment is very important in this. We drop 2 things. Like once the PDU, we drop using the impairment tool, we drop the PDU and drop the data traffic. So we have to get the actual measurement. That's intended output. We have to get it. So in high availability is just we do the failover, and the statistics should not reset. We should not get any anomalies in the values. All all should be intact, because statistics are very important in this. Sorry. Yeah. So the soak test is running for, recently the discussion on soak test.
Yeah, that's applicable.
It's a pretty big topic. So why we is running, what is the statistical way to analyze this, why we are running, I'll take a quick minute on this, because we are using different software functions. It's not because that function changes when we using multi-dimension scale, and it varies in a period of, let's say, from T0 to T dash. So we want to measure how is it stable. The system is stable. That's, as Al pointed out, pass or fail is a function. The performance, this has to perform. So we have to measure at in various time period. It's working fine. That's the main function of soak test. So we are running it for 12 hours. So in that, our intended things is we should not get any core or the memory leak. It's what the intended thing is, like what all it was in the T0. the memory usage, everything should be the same in after T dash. There should not be in spike in that, so that we are plotting in the graph. So that's a performance. Correct me if I'm wrong, Al. So that's the main goal to do this, because that we do in most of the tests. And reliability is it is running a period of time, and the statistics should not show any spikes in the readings. So, and in various load factors, as I said, 40%, 80% of the line rate, sometimes we don't send the traffic for a period of time, but this statistics should, what all it was there, it should show in the actuals, and the various load rate, it should not fail. That's where this variable or this term to measure this. So next step, Al.
Oh, want me to read those for you?
I'm requesting, if you have comments, feel free, and we have sent a couple of reminders, so please feel free.
So who's read this draft? I see 2 hands. Okay. Comments from those who've read it?
Yeah, Mario, I kind of skimmed through it. I can't claim I read it in detail, but there's one thing that caught my eye. You say line rate, but you don't, like, there's no reference. What do you mean by line rate?
Okay, line rate, what do you mean is, like, if say it's if the the interface capacity is 1 gigabyte, or the 1 gigabyte per second. So the 80% of the line rate is 800 Mbps. So we send the traffic at 800 Mbps. 40% is 400 Mbps. Okay. And 0 is nothing, without any traffic. So that's the line rate. That's we use a term in the testing, actually. That's called line rate. So we'll definitely update that.
Okay.
What exactly is that?
Sure. I understand line rate, but I meant in the context, what I thought you might mean maybe throughput. Like you want to first see if there's any, you find that spot where there's no packet loss, right? And then do that. So I was trying to make sure that's not the case.
This is what we are meaning, the line rate. So
Okay.
does that answer your question?
Yeah, it's okay.
Thank you.
Okay. Let me interrupt just for a moment. Where is the blue sheet? Okay. Who has not signed the blue sheet?
Whoa.
Please sign the blue sheet. All those hands. Everybody walk around, grab that sheet, because I'm noticing how much more full the room is since we got started, and I'll bet it was about like half of you who signed it. We want a bigger room next time. All right. Sarah, you've read the draft. Maybe you've got a comment or two?
I have enough comments to last for another hour. So how about I take my own advice and I will send my comments to you on the list.
Sure. Do you have a big one that you'd like to try to take care of now? I put you on the spot. I'm sorry.
Well, so, I think there's some discussion to be had around the soak testing. Can you go back 2 slides, Al? I think it was 2 slides back. Since you put me on this.
You can probably do it too. But...
Yeah, soak.
Yeah.
So under soak, I think I have some comments there. I don't know if it's only about core or memory leaks when we do a soak. And I'm surprised, considering you're testing a core router, that you proposed 12 hours. But again,
72, yes.
no, I'm not a proponent of 72. I was just
that's a
surprised
standard.
that.
I agree, that's a standard, because the performance monitoring, we said, because the statistics and the counter wrapping, taking the line rate, say 1G as a standard point, so this should not happen. That's why we stick to the 12 hours.
Well, I think you're also making an assumption on implementation for counter wrapping as well.
No. I'm telling, like, 12 hours is what we defined as, so the counters.
I see. I understand that's where you're taking or putting the mark in the sand. I'm simply saying I have some thoughts there.
Yeah, sure.
Could you go to the next one, Al?
Yes.
Please. And then under reliability, I also have concern here. So I skimmed this part in the draft. I really need to go back and reread it, but I'm not entirely sure if this is as robust as I would have expected reliability to be. And considering, in most tier ones, you're going to see, in most service provider networks, at least, you're going to see a certain amount of SPFs happening even per minute. I'm not entirely sure if having a steady flow of traffic or throughput for 12 hours really buys you any value, because I don't know if it necessarily has that relation to real world, as the case may be. And maybe it's as simple as modifying the traffic rate or fluctuating the traffic rate over the N hours, and that's fine.
Yeah, that's because, yes. That's a good point.
Yeah.
We'll
So,
definitely add
so
that.
I'll bring the rest to the list because he put me on the spot and I had sort of decided to stop and go to the list. So
Sure, I'll update that. That's a good point. Yeah, the real world, it won't be a steady flow. So it will be fluctuating from, say, for X packets per second, it will be X minus 10 or X plus 10. Is that what you mean? Like you have to have a variation in the flow, traffic flow.
correct. And
Yes.
then even there, a lot of times when I was doing this, I would also modify like I said, the number of SPFs happening per second. So there was a difference in convergence as well, because that often makes a big difference on memory utilization, not necessarily the traffic throughput.
Mhm.
And then bursting, are you bursting? Are you not bursting? Is it micro bursting? Are you,
Okay.
how and where are you doing that at in percentage of load, of line rate? And I mean, so I could go on, but let's go back. I'll take it to the list.
Sure, definitely. Please feel free to send us the comment. We'll incorporate that.
Sure.
Thank you.
Yes, thanks for your review. And speaking of review, who in the room is willing to review this draft and provide comments on the list? Marius, okay. Costas, Pentecoustis, okay. So
When
at
you
least
raise your hand, you're on the record. Just
so at least two people. All right. Before we're done, I'd like to see more reviews.
Yeah.
So even before we consider adopting this. So
Sure,
so let's
we'll do that.
so let's as a working group, we need to consider that. Thanks.
Thanks, Al. Yeah, I will do the all the updates.
All right. Let's get rid of this one. So now it's not this one.
it is.
Yeah.
EVPN, yeah.
But no, that's PVB EVPN.
Oh.
There's two EVPNs.
One is
I got it. Don't worry. There we go.
Bless you.
yeah.
Okay. Go.
So this is about now EVPN is recently introduced as RFC. So we are defining a certain parameters to benchmark this function. So what's the benefit of EVPN is like, both P can forward simultaneously the traffic, unlike VPLS. The VPLS, at one of the P will be forwarding the traffic, other will be a standby. But here that's a benefit of EVPN, and it as well as the MAC will be learned in the control plane. So that's load balancing is one of the key feature of this EVPN. So comments is terminology changes from Al. So from Ramki, leverage on the previous work in the BGP. So this we incorporated. So this is our topo, and the DUT we have connected in one of the multi-homing segments.
Incidentally, where's the test equipment in these topologies?
Oh, DUT is there. The traffic generator, I missed that.
Yeah.
Oh, I missed that. Sorry, R1, the line was there. It was that was missed.
Yeah, it doesn't show up on my screen.
Yeah,
in either form. This is the PowerPoint I've got here. So
Oh, sorry, it was missed.
yeah.
The RT is connected to the DUT as well as in the R1. R1 there's a line, so forgot.
Right.
So
Right.
there's a RT which is connected to the DUT as well as in the R1 there's a line. Forgot to put that traffic RT there.
Okay.
Sorry, apologies.
No, just trying to help other people who are seeing this for the first time.
I'm sorry, actually, it was missed from my side. Sorry. So these are the parameters we are defining it, to benchmark this EVPN. That's MAC learning, MAC flash, MAC aging, high availability, reliability, scale, convergence, and soak. 8 parameters. So the MAC learning is what we are measuring is the time taken to learn the MAC in the data plane, locally, and the time taken to advertise, because the MACs will be learned locally as well as, but the BGP will advertise this locally learned MAC address to the remote peer. So that's a time we are measuring it, and and measuring the time taken to learn the local MACs as well as the remote MACs from the peer. So the 3 time we are measuring it. One is, let me explain. One is the locally learned MAC, was the time taken to learn, say, X amount of MACs. Second is the time taken to advertise this MACs to the remote peer. And third is the time taken to learn the remote max. So these three we are measuring in measuring in the MAC learning parameter. In MAC aging, as when the traffic is stopped, we are sending 100,000 MACs and the traffic is stopped. It has the local, from the routing, from the traffic generator. So it's connected to the DUT, and once it is stopped, so it has to age out. So we are measuring the time taken to age out locally without setting aging time. We are not manipulating on the aging time, or how long it will take to age out. So, and the time taken to from that's local as well as the remote in this MAC aging parameter. And the MAC flush in terms that is simulated by link failure. The locally the PEC link, that's a DUT to seal the RT link is failed, and the time taken to flush out that, and as well as when the remote RT to the R1 link is failed, how much time it takes to withdraw the route via the BGP and flush the MAC entries. So that is we are measuring in this. So high availability. So it's like when we do the routing engine failover, we are expecting 0 packet loss, because all the the MAC everything in its high availability, and it should be synced, and there should not be any traffic loss. And reliability is, when it is in the DF election, when one of the PE that is in the DF election is because in EVPN, the main function of the EVPN in the multi-home segment is one of the router will be the designated forwarder. He will be he will be broadcasting the bump traffic to the local segment. So suppose if I bring a new PE to the system, that there should not be any problem with the DF election. So DF election is the algorithm is V mod N. The V is the VLAN, the active VLAN, and N is the number of P's in the system. So the DF election, once the new P is brought into the system, the algorithm changes. So it should elect the correct DF. There should not be any issue.
Where did 3 seconds come from, Sudhi?
3 seconds is from the RFC.
That's
7432.
So it's safe for us to test with a limit like that because
Yes.
it's in the RFC. Okay.
It is in the RFC. It is.
We're not setting an acceptance threshold there. It comes from the RFC.
It is defined in the RFC.
Yeah, yeah.
7432. They
Okay.
said 3 seconds. The DF election should.
Yep. Good.
And this is a scale. We are doing. We have taken one of the input from Ramki. So we have taken 2 scale. That is the normal scale, how the system works, and scale convergence. Like we simulate the link failures in the core link failures, and we measure the time taken for the flood. This is 100,000, so 1 million max, so 500,000 max from the local and the remote. So with the 8K EVI, EVI is nothing but the EVPN instances. So, and this is just with the traffic, how we measure the scale performance. And another is the measurement scale convergence. Like the same setup, we simulate the core failure so that there should be a withdrawal of the remote routes and started learning. So the flood, but till such time, the DUT will be flooding to the core. So we are measuring that, the time period of the flood. That's very important in the provider world. So that's one of the parameter. And the soak test, we are again.
So we've covered this twice now.
For 24 hours. So because 24 hours with 1 million max running into the system, like 500,000 locally and 500,000 remotely for 24 hours. So
all comments on that previously are applicable there. Yeah.
So there's a next step.
All right. So it looks like you're done. We have questions at the mic.
Okay.
Hi, this is Carsten Rosner for the NTC. Generally, bless you. Generally, the test methodology says like measure something, like measure that these max are learned, but it doesn't say how. So if we look at RC 2889, which admittedly is sometime old, but it usually requires that this is measured on a data plane. Like if a MAC is learned, so 2889 says like verify on the data plane that there is no flooding anymore. Coming from a router vendor, I would guess that you would want to go into the CLI and just see like count MAC address table pipe you know, make a rest-stable pipe count, and then so like, oh, there are 2 million entries. Oh, everything has been learned. My experience from an independent test lab perspective is this is not proof. So I would recommend in general that there should be either some reference to RC 2889, just measure it in the same way, that since the test cases are similar, or describe how exactly the procedure of measuring the results should be done on the data plane. Not on the control,
Okay.
not on the management plane.
So kindly give us in mailing list. We'll definitely dig upon that. But normally, as I said, normally what we are measuring based on the 7432 RFC, like there are two types of learning in EVPN which are happening. That is, the local will be in the data plane, and the remote max will be coming through the control plane. So via the BGP. So
of course I understand. Sorry to cut you off. I know it's a BGP test in the end, but my point would be like, this is no proof.
How did you confirm it is his point? And I would have raised the exact same question, although I would have also done it via CLI, but I think that's his point, right?
Of course,
yes,
I would
that's
do
a
it in
valid
the CLI
point.
in the first place.
Yeah.
Sometimes.
And
So-
it's valid to at least
Yes,
comment on, so.
Definitely. So if you can mail us, definitely we'll work on that. We'll communicate through the mailing list. Yeah, sir.
Hi, Boris Hasanov. Similar question. You mentioned 8K EVIs, right? So
Correct.
we need some like explanation why 8K is not 4K, is not 10K. So
Oh, he's got a good point.
That's a good point. So the 8K is we randomly picked one value. Based on the service requirement. That's a good point, because normally if the services which used in the vendor that studying that pattern, so we have reached to that limit. It's not a hard line. I mean, it's not. It is true. You can go 4K. Because 8K is where the maximum service, the scaling of the services. That's the reason we went to 8K.
So I think having a comment in the document around that and doing one of two things, either justifying the 8K,
Mhm.
which I think is fine, but it leaves you more susceptible to questions,
Mhm.
or specifying the N where the user fills in the N,
That's
and then having some conversation around why we would pick the 8K, for example, is
Okay.
how I would have handled it. I think both valids or approaches are fine. It's up to you. It just one gives you more coverage than the other.
That's a fantastic comment. Like N, so that let the user pick up the N.
And then making sure it's apples to apples if you're
Apples
going to
to-
compare.
Exactly.
Mhm.
That's a good point. Definitely. Yeah.
Pierre.
Sir.
Hi, Pierre Lynchix, yeah. Hi, Sunil.
Yeah. Hi.
For measurement, reliability, and scale, what are the performance metrics we're measuring here? It doesn't seem, I don't see anything. Are we measuring performance?
Yeah, we are measuring the performance. These are the parameters. The reliability is, in different condition, the system should perform. So that's one of the test cases we have taken. I mean the DF election, because that's for the RFC 7432, the DF election. So that's where when the new PE is brought into the system, or the say n number of PEs are brought into the system, the algorithm should not change. There should not be any anomalies. So that is where we are testing it. We added this as one of this section in the reliability. Because in different condition, correct me if I'm wrong, the system should work.
Yeah, Pierre again, Ixia. I get the test, but are we measuring performance?
Mhm.
That's what I'm wondering,
Yeah.
and the scale as well. It's a test, like you said. This should happen. It shouldn't have any errors. So is this the complete test plan working group or the benchmarking?
No, this is benchmarking. This is reliability is one of the parameters. We have 8 parameters defined. Reliability is one of the parameter we defined. Correct me if I'm wrong, Al.
Well, this is, but it doesn't sound like a performance characteristic.
Okay.
That's what Pierre's pointing to.
Okay.
And so it sounds, at least what in the description I've heard today, I haven't read the draft in one version, but to me it sounds more like a functional test. You're looking for no errors, and so let's look at this in detail and
Definitely.
And there's sometimes a way to word these things so that they don't come out pass fail.
Okay.
And that's what we prefer here in Bmwg.
Okay.
Quick one, Marius, and then we got to move on.
Yeah, so just
Marius, yeah.
I'm trying to clarify this. What's the output? So what's the result that you could get? I think that should actually answer your question. Why is it a functional test and not a performance test? Is it 532? Like, is that the result? Is it yes or no?
No, what is I'll tell you is V, as I said, this algorithm is V mod n. So if n is the number of P's, so we are bringing up a new P into the system. The result.
And so what's n? That's what you're outputting.
The n is the variable wherein we are adding one more P. So n becomes 3. Earlier, if you have seen our topology, there were n equal to 2. Now, suddenly we are bringing a n equal to 3, a new P into the system. So the algorithm should work as expected. That is there. It's not pass or fail. The algorithm should work as expected. Like we should get the correct P.
Okay. Well, I'm looking for the update. So currently it doesn't show that, or I don't understand it like that. That's it. Yeah. Thank you.
I'll rephrase it as Al says. Definitely we'll do it. If the community says if that doesn't suit that, then we'll remove it. We'll take out. Correct me if I'm wrong.
Sometimes that's the easiest way. I mean, you may not be able to test everything here under our charter. So let's hear about this other one, which seems to have a lot of commonality with the first one.
Exactly, you are correct. But this is also another RFC. But the EVPN, the MAC learning, as I said, it's in the control plane. But here, what it happens is like because of the it is taking a lot of time. What they have done is it's a MAC in MAC. Instead of in each MAC advertising, they will be configuring a BMAC. So on behalf of other MAC, that BMAC will be advertised, and the customer MAC will be in the data plane. There no more control plane learning for the customer MAC, other than the BMAC of the provider. So that's a difference. This is a different RFC.
Right.
So I hope we are clear.
So it's a different focus, but it looks like a lot of the same tests.
I mean, if this is, we are focusing on a different, but the parameters we have defined the same for the EVPN and because both it's all BGP dependent. So we have and the MAC dependent. So we are defining the parameters. So that way it looks similar. That's correct.
Yeah.
If you see if you want to add, please let us know. We'll definitely incorporate that. So this is the agenda. So as I already mentioned, so this is a new RFC which recently introduced, RFC 7623. Earlier, it was PBB EVPN drafted us turned to RFC. So this is what is the difference between, I'll tell you in quick about EVPN and PBB EVPN. The customer MACs are learned via the control and data plane in EVPN, but here the customer MACs are learned in data plane. So that's a difference, and there will be a MAC in MAC, like will be additional encapsulation which is going on. So, and the same features of the EVPN, it is there, the load balancing, capability, and as well as the two Ps can, in active scenario, two Ps can forward the traffic to the customer segment. So here also missed that line, sorry. That RT is missing one line, and this router tester is connected to the R1 and the DUT. So these are the parameters we have mentioned, the same parameters as Al said, similarity with the EVPN.
Yeah, sorry, Marius Dortescu. I was wondering, it looks very much similar to your previous methodology.
Yes.
Why not have just one document and try to generically add the, I don't know, a special section to say the differences between the two? Because if we have a benchmarking methodology for every protocol that comes out in the IETF, I think that's
it's a lot of overhead. I feel the same way, that this could be easily combined with the other one.
Sure, that's a good point. If that is there, we will add as a subsection. Marius, correct me if I'm wrong. You mean a subsection to that? Adding to that, okay, this methodologies can be applied to this, and we measure that, because the measurement scenario is a couple of things are different in PBB VPN.
But you can have different sections in the same document for that's just my opinion.
Fine.
You may have a different one. I'm not.
So I think we suggest that you take a look at seeing if that works for you, and if it doesn't, then bring it back to the list. That's fine, but I suspect you're going to find that it will.
Yes, we will try it. Marius will definitely try it. Combining that in the next meeting, we'll definitely do that. If adding a subsection to that, okay, and like inheriting that, we'll definitely try to look in. If, as Sarah says, like if any issues, I'll come back to the list. We'll do that, definitely. Thanks for the comment.
Kostas Pedikousis, Travelpink. So I would second Mario's proposal. I had
Sure.
a very quick look through the drafts, and I think it makes more sense.
Mhm.
That may mean that you need to change the title as well of the document. And since I got volunteered for the review, should I wait until the merger happens?
Oh, no, you volunteered for the Y1731
Okay.
performance metrics one.
Right.
So if you,
But I had a
so
look
if
at-
you're
I mean,
volunteering for all three of them now, you win the prize.
I know. So, but I think there is a lot of overlap and stuff like
Yeah.
that.
Yes,
So-
you are correct, because both depend on the payload of BGP. So the scenarios are almost intersecting. So if you, if I wish
Right,
to be
so-
clubbed, definitely I'll club that.
Okay. So I'll do the first review and then.
Definitely, that's a good point, and I really like that point. We'll do that.
Has anybody else not signed the blue sheet? No one else?
So,
Do you want to continue going through, or, because I don't want you to sit up here and take a nice big long review that's the same,
Yeah, so as we wish, for the interest of the time, is the parameters the same, the community sees, then it's fine. So I can, because mostly the same thing, except the Mac learning parameters, it's changed there. So it's parameters, what the 8 variables are same for EVPN and this. That's fine.
So who's read these drafts? Skimmed, your hand counts.
Yeah,
Who's
well-
willing to read these drafts? Okay, I will
Three
too.
guys, including,
I'll help you.
I didn't catch your name before, the gentleman with the baseball hat who made the good comment. Say it again.
Boris?
Boris, thank you.
Fine, that's Mary's, and we'll definitely club that. So thank you.
Behind the mic?
Thank you for the comments.
No,
With the
with the
black
red hair?
glasses?
No, I don't know.
She tapped his name, he's put his hand up. Oh, sorry, not him. 3 rows behind. He's got the polo shirt on,
Oh,
the gray shawl.
yeah, he had his hand up too.
Right.
Okay.
That's it.
Okay, thanks very much.
Thank you.
So I know you got cut off, but we're very interested, so.
I'm sorry.
You got cut off here, I know, but we are very interested, and I'll definitely support and read through as well, so please don't take it otherwise.
Anyway, parameters are same, it will be monotonous to the community, so it's better. So we club as a subsection to add that. That's a good comment.
Okay.
So we have to measure a service, and this is as subsection, it's fine.
Okay.
As long as it's there, it's fine.
Okay,
Thank you.
thank you. So you've got 22.5 minutes, Jacob.
I'll go quick.
Yeah.
So Samuel, I think, is online as well. He was the lead author on this paper. I don't know
My bad.
if you can hear him or not.
Well, if he joins in the
He is.
in
He's
the
here.
queue, I think the thing to do is have Samuel join the queue, and then when a question comes up,
Yeah,
that he wants to
exactly.
answer, we can add him.
Exactly. Okay, cool.
Okay.
So Sam, if you can hear, please join the queue. So, so this is kind of a new proposed benchmark around network virtualization, and a look at it from more of an application point of view, not really an NFV point of view. So I think there's very distinct differences when we look at a network function being what the vSwitch sees or hypervisor or whatever you're doing versus it being an application.
Sure.
And then extending the network virtualization. So if you look at the NVO3 working group on like using VXLAN or Genev or anything else like as an overlay going across that, and what performance considerations need to be taken into consideration when we look at the kind of that end-to-end piece. So if we've kind of framed the draft as first kind of going over what's the differences between physical benchmarking versus benchmarking something in that lives, and a lot of the components live within a server. So there's a lot of different considerations, whether it's the NIC offloads that you use, even the MTUs are different, right? I mean, if you just put like a VM that's an Ixia, for example, or just just any tester, doesn't have to be one particular tester and to start blasting 64-byte packets. That may not be representative of what the application is actually gonna do, because a lot of the offloading's taken into consideration, and you're dealing with like 64K, 64-byte chunks or 60. I mean, really large chunks of data, not necessarily like packet by packet. You're seeing this kind of big macro view of things because that's what the NIC is offloading and doing. So the hypervisor and everything else and the vSwitch never even see those 64-byte packets that take place. Again, scope, talked about not NFV, but kind of this hypervisor-based network overlay function. Application layer benchmark, so working closer to the application segments. So we recommend, as we go through this draft, different types of benchmarking that can simulate more of a real-world application versus kind of just blasting a 64-byte packet, which is not going to represent what an application is going to do within this environment or what the hypervisor or switches, vSwitches are going to see.
So applications here are really things above layer 3, 4. They're what's an example of an application?
Yeah, I mean, I think the point I'm trying to get when I say application is that it's not a packet generator. I mean, ultimately an application doesn't matter. It's just like looking at TCP streams, right? For example, that are going to be. I mean, when you look at the components that are going to interact with that, it's going to be a lot. You're not interacting with, like, say, a single packet.
So you want to generate traffic patterns that
Yes.
are similar to what applications would generate.
Yes, correct.
And I think other people agree with you that that may produce different results. So
Yeah, so repeatability is going to be an interesting. Yeah, so that's why during the
it's going
tests
to
we
produce
have to-
different results, and the repeatability may be affected. Yeah.
Yeah.
And you said overlay a couple of times here, but I noticed I don't think I see that word here anywhere. So
it is covered. Yeah, I didn't put it in this summary, but yeah, it's a miss that we do in this draft cover the different overlay scenarios. So actually, how we deal with an overlay that
you mentioned the network
starts and ends within a single server, right? When you don't really have an overlay because you're just switching the traffic, or maybe the overlay ends at a physical hardware endpoint.
Do you have a quick clarification, Ramki?
Yeah, very quick.
Okay.
So just to clarify, even in the case of network functions, we have some advanced functions, say, for example, TCP proxy, HTTP proxy, which kind of behave like an application. So I would say definitely there's an intersection between
there's some, but it's like, there's.
So I'm just saying it's not like NFE. When you're using overlays, even in the NFE context, it's a lot of similarities. So I wouldn't say it's like NFE is like completely separate. There is a commonality. That's what I want to
Okay. Yeah. Okay. So the overlays are taken into consideration in this document, and again, what I was mentioning before, it's the where they start and end, what you need to consider. So like the system under test, for example, is a lot broader now, right? It's not a device under test; it's a system under test where you have all of the components within the server that are doing their functions, but then you're going out on the network and you're going through physical hardware switches and so on. So there's a lot more to take into consideration. So this document doesn't really go as much into methodology, but more about what to take into consideration when we're doing benchmarking around these network virtualization platforms. And scale as well. So how these all will scale differently now that we're kind of living in software for most cases, but in some cases we're not, right? I mean, if we're going out and hitting a physical endpoint that does a decap and encap, then that's a whole different scale measurement. So a lot of different scale considerations when we're looking at the overlays as well. So kind of going on, I'll run through these quick because I know we're short on time. This is an example of the differences, right, of the switches. The packet size are a function of RSS, TSO, LRO, et cetera, by default 65K, where when you're benchmarking a network, you're looking at, okay, I'm going to just run through this like 64-byte packet, 128-byte packet, and so on. Multi-port, generally 2 ports, all the NIC offloads, DPGK, et cetera, that we're dealing with. Again, so this is just another example of the what I just mentioned before, right? CPU-based TSO, we're going to do MTU, but NIC-based TSO, we're looking at 65K as an example. Again, receive side scaling is going to cause a bunch of different issues as well. So this kind of just brings up the point of when we're in the system, all of these things matter, right? So documenting the receive side scaling, because as you're doing that fan out to the different cores within the server itself, you're going to see different performance considerations. So when we look at the different response times, and this is kind of an example of benchmarking that we used in the past, and just kind of starting a list of, okay, well, if we look at different applications, what are the different page size and response times that are expected, right? The 2 meg, 56K, web response times, memcached response times. So each application has different response times as well. So when we look at latency, it's not just latency anymore, it's a response time that we're getting. And then example methodologies that we've used, right? Like the application throughput using Apache benchmarks that we have out there. memslap is another example where you can kind of really hammer a system. iPerf and Avalanche as well. So just different areas. So I mean, that's all I had. First take at the draft, and I don't know if there's any comments or questions, if anyone's read them yet, or if you haven't, please do so and comment.
How many folks have read the draft? Oof.
But 2 people have questions at it.
Yeah, Mario Georgescu, I haven't read the draft, but as you are saying, yeah, how would you think, or how would you consider repeatability, like solving the repeatability problem, since there will be one, I imagine, in this context?
Well, I mean, I think as long as you run, like, say, if we look at some of these tests, right, you can run that test. Okay. Right, and it should be fairly consistent each run that you actually do. From
so yeah, multiple iterations.
So it's not like you're just taking an application and running it, but you have to take that into consideration too, because the CPU is going to act differently, right? Say if you have, I mean, I think what you did in the end, your draft is just like, okay, well, how do you deal with a noisy neighbor?
Yeah.
Right, in those scenarios. So I think that will have to be taken into consideration as well. So it's a good point.
Yeah, so I'm imagining there's since this is not specifically a traffic generator, the file size or the data size will be different maybe each time. So that's what I mean. Like, how do you, even if you repeat the test, of course the result is going to be different because the data transferred is going to be different, right?
Well, if we have to specify like what variables you're actually putting in to do what data transfer.
Yeah, I guess that's right. Controlling those would be critical.
Yeah, exactly.
Okay, thank you.
I'm going to cut the lines at the gentleman with the red shirt. And so please make your comments to the point and brief. Thank you.
Okay, Maciek from Cisco with the FDIO hat. Do you treat your DUTs as or SUTs as black boxes or white boxes? And if white boxes, I guess the level of telemetry that you expect to, I guess, dictate in the draft going forward?
Well, I mean, that's one thing that we mentioned actually specifically in the draft, is that we can't necessarily treat it like a black. I mean, we have to treat it like a black box from a benchmarking standpoint, but we have to document what's in that black box. We can't just say, here's a black box.
Right.
We have to actually document what's inside, right? So that you can take
Just like
into
we've
consideration
documented configurations in the past.
Yeah, exactly.
Configuration, but also operational data, or no?
It's okay to collect the operational data, but it's not part of the benchmarks.
Okay, we're almost in agreement, and I'll volunteer to review the draft. Thank you.
Very great.
Stephen Wright, AT&T. So I was confused by the text in section 2 where you're trying to describe what the platform is that you're testing. Because you have sort of one sentence that says it's not NFV, and then a bunch of other things that I would have thought would have been included in NFV, and I don't think they really capture what you're actually trying to do. So some wording improvement would be helpful.
Okay. Yeah, please send the comments on the list.
And thanks for reading it, Steve.
Katalin Meiros, Ericsson.
I'm sorry, could you say your name slowly? Nobody does that. Everybody goes. Blah, blah, blah.
Katalin Meiros, Ericsson. 2 quick comments. One, it's about the fact that this goes very close to benchmarking cloud environments. And for benchmarking cloud environments, there is a lot of open source software out there that actually takes into account a lot of the conditions that you mentioned and the repeatability. When it comes to the repeatability, a lot of the testers from Ixia and Spirent and other companies, they would do layer 7 testing repeatedly. Yeah, so that's one thing. The other thing that a lot of academics do, they replay traffic traces. So you get repeatability through the traffic trace. And I can comment more on the mailing list.
Okay. Yeah, please. But yeah, I mean, I think the traffic traces, as long as you can, is stateful, right? I don't know if because you have to take into account that.
Yeah, you would do TCP replay, for example.
Okay. Thanks.
So you're committing to take this to the list?
Yeah.
Okay, I think it's very important because Al started out the working group today with that single factor variation, and this clearly obliterates that, or it certainly calls it into question, which is not in and of itself bad. I don't think you can not test. You can test in a not NFE but NFE world and then have single factor variation. So it's going to have to come, but having that discussion, I think, will certainly help alleviate all of the conversation that's going to ultimately get to where he's going to go anyways.
Sure. Okay.
So, and by the way, if Scott Bradner were here, he'd be jumping out of his chair 5 minutes ago. So let me take that point for him. All right.
So Ramki Krishnan Dell. So we also have what you're doing in OpenStack is an extended work around all these, essentially looking at all capabilities, NIC switches, vSwitch, several common capabilities, which is applicable to NFE and also applications. So I'll send a link to the
NFERG.
NFERG. So kind of this is actually happening in open source, where open source meets standards and applied research. So I'll send that link to the list, and perhaps I think worth taking a look. I think there is extended thing much beyond what you're talking here.
Great.
If it gets adopted anyways, Jacob, we're going to ask you to liaise with or take it in NFERG anyhow. So it cuts.
Okay.
Yeah.
And I guess my final comment, just kind of as both as an author and a co-chair, is that we want to be sure that this draft is clearly distinct from the other ones on the larger considerations, which take into account not just VNFs but the whole infrastructure here. So that scope is large, but about considerations, not about methodologies. So it may be that there's some things that you've brought up here that need to be followed up with methodologies for sure.
Yeah.
But so let's think about how that would work in the future of keeping things kind of distinct.
Yeah, absolutely.
Yeah. All right. Good. Thank you, Jacob, and thank you, Samuel, for being available. All right. Okay. So now we've got our two invited talks, and Daniel's going to come rushing to the microphone. This is Daniel's first meeting with us here in IETF and in Bmwg. So I would ask you all to welcome him and listen to his talk carefully. Daniel, please go ahead.
Yeah, thank you. This talk, I gave it originally already on Saturday, so I will try to shrink it a little bit in order to keep in time. Just to say a few words, I did this work together with my colleagues. Sebastian Gallenmüller and Paul Emmerich already gave a talk here, I guess, or some information about the Bmwg project some time ago. Yeah, it was quite I will dive into the content. So what we did in the paper was we made a case study and benchmarked several software routers. And then we had some big discussion where really a lot of discussions between all authors, and we somehow documented the outcome about what are the flaws of current best practice, and we suggested some solutions to that. So to summarize, we are really focused on those kind of routers which have a CPU and a lot of cores and all those problems that are in there with parallelization and cache hierarchies. And yeah, so I guess I can skip the reasons why to revisit these old RFC. There were some changes in how routers look today, or interconnect devices. Our setup was a 10 gigabit link, or two 10 gigabit links between our RFC test suite and the devices under test. And this devices under test, we had two routers running on the same server. So, of course, not at the same time. The one was a Linux router and a FreeBSD router, and the MikroTik router we choose because it's quite typical for those low-cost devices with, in our case, the router had 36 CPU cores and did everything in software. So it looks like an ordinary switch you can place in a rack, but actually it's doing everything in software. So I will directly dive into the discussion. So in our case study, this was a result of the FreeBSD router. And one problem about measuring latency is the RFT just says use the average. And if you look at the average, that would be that value, and that fits the most amount of the samples we did. But there's this long tail, and it's not really reflected if you point or if you use the average. So the problem gets even bigger if you look at other devices. This was another device we did not benchmark in our case study, but used for argumentation. It's a PK8 switch, and every time you have different processing paths inside a device, you see different kind of latency behaviors. So in this case, it's bimodal, but can even be more than 2 peaks. And yeah, here the average latency is clear and not a good selection. So we suggest to use either histograms if you have enough samples and want to visualize it, or for reporting and comparing to use percentiles. I guess it can be a discussion if you really need all those or more a lot, but we suggested to use those.
Let him go a few more. Yeah, thank you.
Yeah, I don't mind. Sorry, I didn't know. Okay. Here we did that with 25 and 75 percentiles for latency, and the next problem is the RFC, or it's common practice to use the maximum throughput load, or there was also a recommendation to use 80% load, for instance. Actually, we proposed, or I first explained the graph. So the graph is we increase the load stepwise on the x-axis, and the latency is plotted on the y-axis. And what you see is shortly before the system is overloaded, we actually get the best latency. So the assumption that using the maximum throughput load for latency measurement is some kind of worst case does not really reflect in that system. So we can also explain that yeah, it's some behavior of batching and the driver doing some optimization, and then CPUs a little bit more efficient to work the packets or get the packets done. Yeah. So what we suggest here is do not just use one rate for measure your latency, but measure it always when it's possible. And yeah. The next problem is same graph, but I added the behavior for a different kind of traffic. So CVR is the one traffic that is you should use, but then there's a recommendation, please use other traffics, but usually CVR is the most common one we have found. And this behavior I explained, it is removed if we had some Poisson process generated traffic. Why did we use Poisson traffic? For our reason, we could do it, we can do it, and it has some self-similar behavior, which we thought is for short time scales more realistic, or can be found in the real world, and it has some additional good behavior, so you can combine different Poisson generated traffics, for instance, which you cannot do with CVR. Yeah. So keep an eye on which traffic to use for your latency measurements.
This ties into the point we were talking about with Jacob and the new draft there. Yeah. So we had to think of some new traffic patterns, but controllable stuff. When TCP control loops involved, go ahead.
Yeah, totally. Another thing I just want to discuss shortly, some tests can be omitted. So for software devices, you always, we could really omit the frame loss test because it had always the same behavior. After the maximum throughput, packets got dropped by the network card without any additional load. So the graph was always that curve. So we suggested you do not always have to make every test if you have ensured it has no really insight into the device. And there are other tests you should pay attention. In that case, it's routing table size test, where you can clearly see the behavior of caches. So here so we increased the IP addresses in the routing table, and here's the packet rate the system has achieved in the blue graph. And it has 2 points where it really degrades here and here. And actually, this is where layer 2 cache is exceeded, and this is where layer 3 cache is exceeded. So also keep that in mind, that the system may behave differently. So add function-dependent tests if you have certain software. And the last point I wanted to highlight from the paper was we really had problems, or we really had thought about how can we reproduce the results. And what we would propose, or what we propose, is try to make all scripts used for configuration available. So in all those software devices, if they were not available, there was an update on the device, and we were not able to reproduce the test later, So they somehow have to be made available as metadata around the benchmarking report, or yeah. So these were my points. Just a summary. I will skip them to the time constraint, and want to highlight a last thing about the paper. So we did the test not only on commodity hardware routers, but we also used commodity hardware for benchmarking. We used the Mungen framework that Paul Emmerich has presented some time ago here. And we could use hardware-assisted latency measurements by misusing the PTP support that each inter-network card, or at least the bigger ones, provide. We did precise rate, software rate control. Come and just read the paper if you want to know how that worked. And the benchmarking reports are available on the website, and although the paper is available on the workshop website. So
great,
thanks.
So now the folks can come to the microphone with questions. Daniel, thanks so much for presenting this. Let's we've certainly got some time for questions here.
Right. So Kostas Pedikousis, Travel Pink, thanks very much. This is great work that you guys are doing. I would like to go back to that figure that I was trying to comment.
I think it was this one, right, Kostas?
No, the previous one.
This one?
Yes.
Yeah.
So I think you guys have had some kind of discussion here already. And the first thing is, how many people in the room have read work done by Edward Tufte? Or, the visual display of quantitative information. So not so bad, but not that much either. So my favorite is box plots. It's easy to understand. You need very little, effort. It packs so much information, and anybody who shows me something like that, I send them back to read Tufte. It's not very complicated. I think it's TUFT is the guy. You can Google him. And so anybody who does kind of, any kind of visual display of quantitative information should read that book. I think it's early 80s.
So quick commercial for the
I don't know the guy, I never met him, I just read the book. I think it's highly recommended. And
it doesn't matter. The R statistical analysis tool has all the stuff,
exactly.
all the stuff from S and S plus that I sort of grew up learning to use. And I haven't seen a box plot with whiskers in a long time.
I can send you my papers. So back from the mid-2000s. So the second thing is R, right? So I guess you use it, etc., etc. So R is, if you're going to plot something, don't do it in anything. If it's statistical, don't do it in anything than R, obviously. But I think the greater discussion perhaps here is because I was reading we were doing some testing with some commercial equipment recently, and also for a deliverable in the Unify project. And the question is, do we actually, as a group, think that maybe 2544 needs to be revisited?
You are welcome to bring a draft to that particular persuasion.
Yeah. And in fact, I mean, that's one of the reasons for inviting Daniel to give this talk.
Yeah.
This is obvious next step. Thanks for speaking the unspoken.
So I would be interested in this kind of line of work, actually.
Yeah.
And we have had some kind of stuff that is also exactly the TCP things that, there's a lot of work that happened in this measurements area. And,
A lot of this is in the DC benchmark.
no, but I think other people are
Exactly
gonna,
this too.
So, yeah, that's all. Thanks a lot for the presentation.
Thank you.
This is Mario Georgescu. I would +1 Costas on the revisiting. I think, I do think some parts need to be revisited. I tried to do that with the latency in my draft, and like following some discussion I had with Paul, it was like his suggestion was this.
Yeah,
but
exactly.
like again, my reply to that was, aren't those too many? Like we're trying to be synthetic. It's like 25, 50, 75, 95, 99, 99.9. I think the variation, if you find patterns, that's what I try to do. If you find some patterns and they seem relevant, I guess 3 numbers would be enough. Like if you have the first percentile, 99.9 percentile, or maybe 99th and 99.9 percentile might be enough, because it might get too complicated. And yeah, box plots is a solution, I agree, but histograms as well for a fine grain analysis. But the main report should be more synthetic. It should offer more insight to the guy reading it. That's my thought. Yeah, that's it. Thank you.
I think most of the test tools available today, and that includes MoonGen, have gone beyond the sort of the static, very minimal RC2544 latency specification, which was something Scott could do in his lab over 20 years ago, right? I mean, there was limitations on what was possible. So it's perfectly reasonable that we've got lots of things more to say about that, and maybe that alone is a topic that folks could consider attacking.
Let me just comment on that. In the old RFC, it's stated make 20 samples at least. So with 20 samples, you would not even get such a graph. So yeah.
Yeah.
Yeah, Mario, just it's at least 20. So you can it's a lower bound. It's not.
Ramki Krishnan Del. So I was wondering where these
Get
tests
closer to the
done on-
mic there, Rumki. There's something wrong. I can't hear you.
Ramki Krishnan Del. So I was wondering where the tests you did reflecting any real world applications, or more just, you're crafting text for IXIA, so then sending 64-byte packets or IMIX. What was really the objective when you did those tests?
Is that for this stuff here?
Yeah.
So this exactly was Open vSwitch, but the effect is not given by Open vSwitch because Open vSwitch has really a constant.
No, I mean,
behavior.
what kind of application, what kind of traffic patterns were used? I mean, was it just synthetic or IXIA, or something mimicking the real world applications like
we
video?
did not use any real trace, so these are really synthetic for benchmarking. I think the discussion we did not have the position to push some trace, select some random trace and say this is the trace we should always use for benchmarking.
So the reason I'm bringing that up is kind of, as you can see, well, the latency numbers are varying, and we know that if you throw traffic to an Intel processor, because there is caching, it's bound to happen. But does it really matter to the end application, right? For example, if you take something like real-time video, then overall this latency bound, it matters. But standard just web traffic, if you're passing through even a network function, there is bound to be variation. We know 100% that if you feed through a cache-based architecture.
Yeah.
And the question, it probably doesn't matter at all, right? So that's why I would like to kind of, I mean, if you're doing anything with this, probably bring that real application where it really matters into consideration, right? Not just say, hey, oh, we did this abstract test and then conclude results based on that. So
I think your key point is where it really matters.
Yeah.
And you have to run a test to figure out whether it matters.
No, I'm just even questioning, going back and saying, did we run the right tests, or we just crafted tests to prove a point? I mean, so whether test crafted correctly to reflect reality versus just crafting is just a set of standard almost like a black box test.
Could you
Not
repeat
just that,
Could you repeat that, Romkey? Into the mic. Repeat what Carson said.
Are you asking for technical and business requirements? So almost like, yeah, it's not exactly, but somewhat like real world applications where all of this would matter, right? Reflecting to what I mean, when you did a test, what really you're trying to deep dive into versus just running an abstract set of tests.
So I think, I think the problem with going there, into the real world, is in fact the real world's different for everybody. So we should have some set of constant tests that we all agree on, and then everybody can go on and expand that to their heart's desires, to the ability of their test equipment to be able to do that, and so forth, and gain some valuable information from it. We're never gonna preclude that, just like we've never precluded testing with iMix here, although it's it's sort of beyond the general set of things that we really consider. I think what we're talking about with this in particular is a pattern sensitivity, CBR producing some unusual results, and what do we need to do about that in our absolutely recommended set of tests, which don't necessarily look like a real world scenario.
Yeah, fair enough. Certainly, I mean, exactly as you said, the approach is, we did this, but also at the end of it, where does it really matter? In many cases, probably it doesn't matter. That's kind of the point I was trying to raise.
Yeah. Okay. So I just was reminded by my co-chair that we have to switch talks now. Daniel, thanks so much for doing this and for joining us here in the IETF benchmarking methodology working group. And we look forward to all sorts of contributions now from the MoonGen team. And let's see here. This is going to be the last one I got because that's when it was. Here we go. All right. So you is full screen.
So I have 8 minutes?
No, take the full 10 and whatever people want to stay over for questions, we'll do that. Yeah.
Well, still, I guess good afternoon, everyone. My name is Maciek Konstantowicz. I work for Cisco, but here with a FDIO Assisted Tech Project Lead hat on. And I want to spend the next 10 minutes talking about what we're doing in FDIO and how it is relevant to the Bmwg. And I actually wanted to thank you, Daniel, for an excellent intro, because some of the challenges that I'm going to highlight directly refer to what he has described and proposed. So one of the things that we are doing in FDIO, and FDIO stands for Fast Data I/O. It's the play on letters and words. It's pronounced apparently FIDO for faithful dog in Italian and American English. And what we're trying to do, the project has started in February or end of February, beginning of March this year. So it's fairly new. Code has been contributed by the main code, VPP code has been contributed by Cisco as a working code. However, all the system testing and benchmarking code has been developed or is being developed from scratch. And we have this ambition of driving the development with tests. So test-driven development with a feedback loop directly to the coders and the committers. I spent very few high-level slides copied from the FDIO pages, providing the background. So FDIO and VPP is about providing a programmable, fast, efficient scalable, modular, all the words, data plane services. So it's about data plane services on computers. And what we're trying to do, we're trying to make computers be closer to the network, be more aware of the network, and have a way to support routing of packets from computer to the network, to the internet, and also between the NICs if so required. So this small print here, you can read the full article as a blog, but that's what you get when you type HFR in your Google search engine or other search engine. At least this was the case when you did that a few months ago when this was written. VPP is open source software. It runs in a user mode, in a user space. It can run in a VM. It can run in a container. It can run it as a process. It has been developed since 2002, and all of VPP code now has been open sourced. And there is much more information available in the links provided, and I think that slides are posted, Al, correct?
Yes.
So all of those links are available. It sits, if you want to position this in the context of the stack, it sits on top of network I/O. So for example, it is using DPDK to drive the NICs. So benchmarking VNFs. I started doing it a few years back, and that's why I guess I inherited the SysIT project. I wasn't there from the beginning, but I joined the project. And we wanted to start with the basics. Baseline the system, make sure that the results are consistent, they are repeatable, and basically follow the basic guidelines that have been produced by this very working group, the RFC 2330, and focus on throughput and latency tests. And so that's what we set to do. The problem is that any software running on those computers, clearly these are not physical devices. They are not integrated or pre-integrated systems. So there are just software workloads from the computer perspective. And they are different than the traditional compute workloads. So this is a bit of the chart, and Al asked me to increase the font, so I did my best. So hopefully it's readable. It's quite dense, but it comes down to a few points, and I know that this pointer works. We have a very limited budget to process packets. And if you look at the 10 gig speed, line rate 64 bytes, we have a 67 nanoseconds per frame. And to access memory on the 2 gig core, Haswell, Broadwell, fairly recent CPU, say x86_64, it takes 17 nanoseconds to access memory. So we can't access the memory per packet. And that's where VPP helps. VPP does not actually process packets one by one in a scalar manner. It processes them by using vectors. And this is not a unique technology. It is used by some other software. It has, DPDK started to use it, something called vector PMD. So you basically amortize memory accesses over a vector of packets. And the idea is to stay in the cache as much as possible and monitor the usage of cache and monitor the usage of memory. So in order to try to abstract this level of detail to something that one can measure from the black box perspective is hard. It's hard because if you start going out of the cache, your measurements will be off. So you need to look at my comment earlier about white box and telemetry. You need to start working your way down the system and understand what is the system actually doing on a per packet basis, and arrive to some metrics like I listed here, some of them being common to compute workloads, instructions per cycle, some of them being packet specific, instructions per packet or cycles per packet. So that's what we're trying to do in the SysIT. SysIT stands for Continuous System Integration and Testing Project, and within the FDIO, Collaboration Project, Linux Foundation. And we are testing functionality of VPP in this case, and also performance. And we are testing it, the goal is to test it on a per patch basis. We're getting there with functionality, we are there with functionality, we're getting there with performance. So the idea is to give to the coder who is committing the patch this feedback loop.
Real quick, Ramke.
No, I'll wait.
Okay.
So what are our aspirations? We test against specifications, so RFCs, functionality specifications. We are doing RFC 2544 and RFC 1242, but we haven't got a full coverage yet. So we want to get there. And we are monitoring the efficiency metrics of the software, but also trying to monitor and verify the baseline tests of the system underneath the software. This is our recent report. First report, you will see we don't have a latency measurements there because we have some issues with measuring the latency, very much aligned with what Daniel has been discussing. And I'll have a slide on that. This is really a reference, functionality and performance measures on a per core or per port basis. I don't want to go into the detail for the sake of time. It's published, and sysid-dev is the list where we're discussing things. I think there's a set of links. If not, I'll provide. So, problems encountered. We had to learn quite a bit, and we had some, experience from the industry and also from friends and family. But we did see issues with getting repeatable results, and for that we actually had to dive deeper into what is the hardware that we're running on, what are the restrictions of this hardware, including the drivers for the NICs. And the DPT being a driver, well, we're having a lot of fun with that, and we also have a lot of fun with VPP2. We also have a lot of fun with intelligent CPUs. They are very, very intelligent. They are over-intelligent. We are striving to control their intelligence. And this does not just come down to controlling the frequency of the core or frequency of the uncore, but other parts of the subsystem. Lots of fun. So in order to control it is to configure it, but then we need telemetry to monitor it and actually see the effects of the system. We are running tests on Linux, so everything is open source, and we clearly have some fun with kernel. Kernel, even if you isolate CPUs, we're still using, it's still sort of polluting our, it's becoming our noisy neighbor. And a VM environment is clearly, even more complex. So how we are dealing with it? We are adjusting testing methodologies. The basic RFC 2544 binary search, if executed from the top rate down, may yield different results when executed from the bottom up. Why? Because of the intelligent CPUs. And it all comes down to your stop criteria and so on. The other thing is with the latency. The long tails that Daniel has highlighted. Well, there is a jitter introduced to the workload because of the kernel, APIC processes, interrupt processes jumping and context switching the CPU. You won't see it until you measure latency per packet. And that's what we're struggling with at the rate. We can't get it from the hardware tester vendors, at least the ones that we have interacted. And in open source, we actually don't have a budget for the hardware testers, so we are relying on computers to generate packets. We are currently using T-Rex as a packet generator, and we welcome anybody who can help us to bring some state-of-the-art generators like Munjin with timestamping. And we're also considering some other open source hardware like OpenNet FPGA in order to allow us timestamping down to 10 nanoseconds. And we're hoping to work directly with OpenNet FPGA folks in Cambridge to make it happen. Update on this hopefully after summer. And measurement tools, yes, so software generators. More please, more accurate please, open source please. And telemetry. Telemetry is huge. In order to verify that your system, you're getting from the system what you really want and see from your benchmarking, you really need to verify the operational environment of the system, especially that this is not a closed system. This is not an Apple MacBook with hardware and OS integrated. This is COTS. This is common off-the-shelf computers with workloads on them. Variability is huge. You take a UCS, you take a Supermicro, you take something else with the same microarchitecture, unless you configure it correctly and have it in the right, and you monitor that, you verify that it is actually operating correctly as you expect, you will not get the same results. The good news is, it is possible. It is possible, it's just that not all of the telemetry is in open source. So luckily in FDIO, we have Intel folks directly involved with their skin in the game. And we're working with them to publish the closed telemetry to open source, basically using perf tools, and make sure that they do work and they yield something you can rely on. So it can only get better, right? To-dos, lots of them, and quite some of them related to what has been discussed in the Bmwg. I also happened to attend part of the IPPM meeting the other day, and something caught my eye. There was a registry discussion about how to standardize the metrics and how to feed them into something that humans can read and machines can read, that humans can follow and machine can follow without discrepancy or ambiguity.
It's less about machines. There's some machine parsing conventions.
So I am wondering whether having the netconf bug spreading in IETF, whether we could consider, there were some comments earlier today about automation and being able to, but the machines, the robots, to read the results. Not only just by pass-fail or reporting value, but actually taking action on a set of results. So have some structure and try to drive the standardized test automation framework. We would definitely welcome that. And from FDIO perspective, as a project lead, I would definitely make people aware that there is a good work happening here. So hopefully we can attract more people from community to here, and vice versa. I would encourage you to help us drive it faster and more efficient as an industry. Now, one comment regarding VSPerf. I'm getting a lot of questions. We're getting a lot of questions on, is it the same as VSPerf? Is it overlapping with VSPerf? VSPerf is about test verifying performance and benchmarking of virtual switches in the context of OPNFV system. This is sort of related, but it's focusing on being part of VP or FDIO development process, benchmarking being part of it. But we are executing the benchmarks on a per patch, per commit basis. We want those corporates who are funding the project to empower the community so that people who can't afford 12 40DD ports on the server or IXIA can actually use the shared infrastructure. So although there is a commonality of interest there, the actual operating model is somewhat different.
Your scope is this
scope. The charter is slightly different or quite different. And that's it. Thank you.
Ramki Krishnan, Dell.
Hold the mic up.
Oh, it's not going up. Actually. Oh, okay. Ramki Krishnan, Dell. So I was wondering regarding the FDIO VPP scope, is it only layer 2, 3, 4 packet processing, or is it beyond that?
Oh, I apologize. I skipped through this very quickly. It supports today more functionality that's listed here. So it's bridging L2 bridging and cross-connecting. It's got IPv4 routing and IPv6 with fully compliant, RFC compliant routing and bridging stack, no control plane. So all the packets processing is there. There are also VXLAN, Lisp, VXLAN GPE, Lisp GPE, IPsec, and a few others that we haven't tested yet. Full list on FDIO.
So basically switching, routing fully covered.
Well, we also have stateless security, and we have some folks developing stateful firewall. Actually, in fact, two threats at the moment, I think. Okay. So treat it as a packet processing system. And it can be used as a VNF. It can be used as a virtual switch. It can be used as a VNF. It can be an NF in a container, open source.
The reason, it's just like to give a broader context, for example, NFE, we have several different types of network functions. So stateful firewall, IDS, IPS. So today, one of the strategies we do is essentially we bring platform awareness, which means NUMA, CPU pinning, all those in the works.
Correct.
To the level of L3 cache partitioning, which is under works.
Correct.
But that works as a broader set of functions, anything, everything. So how do you see your VPP working with that? So basically, it's going to kind of have that vertical kind of one type of set of functions going there, and then the rest will be handled separately. Is that what you're thinking as you progress?
To be honest, I mean, community is going to decide on how this thing is going to be used. Today, it is used as virtual switch, virtual router, and also as a virtual appliance. For example, Softwire, MAP, and Lightweight for 6 drafts, RFCs are now implemented. I forgot to mention in the last IETF hackathon that finished on Sunday, ILA, ID locator addressing, implementation. We got the first prize. Interrupting, we started on Saturday, all for design was ready, and we showed the interrupt with Linux XDP implementation with Tom Herbert. So it's very, the platform enables rapid development in terms of hardware. The code that is committed and that is tested is expected to be threat safe. And yes, the system is no malware, and it sort of comes to the box. I didn't have time really to explain the system itself, how it works. It's basically a graph of nodes. How it can be used, I think the users will really decide. Yeah, that's really my
But
point.
as of now, is it fair to say that, say, when a system comes up, this VPP takes up a set of cores to itself and then optimizes these functions you described, whereas if you want something else, then you go do it yourself, right? For example, if you want IDS, IPS, you manage the other cores in place.
Yeah. So currently, most of the code is stateless, and it basically, if we run multi-core or multi-thread, we run the same code on every thread. There is hardly any sync. Under law is your friend. We almost have a linear scalability. And there's some published material on the page. There will be more. And the numbers are, as I'm showing here, if you're interested, shipping code per RAS release, 8 to 10 million PPS per CPU. Some improvements with DPDK vector PMD code. So we're working on with community. We're getting really good traction with the DPDK folks. They're really game. And we're trying to engage more. We want more NICs that work, including the offload functions that work at high speeds. Yeah, we need help. Thanks.
Thanks, Maciek. I finally heard the word vector there. That's the most important thing.
Vector, guys, vector is big. I mean, vector,
vector
as a technology.
Vector means traffic patterns, and homogeneous vectors go through this like heterogeneous, maybe not so quick, right?
Well, then you have an adaptive system that actually can adapt to this variety of traffic patterns. And that's actually is a very good point for calling for extended benchmarking methodologies.
Yes.
Thank you all. Well spotted.
Yeah.
Let's do the draft.
Okay. Thank you, Maciek. Thanks, everybody, for staying roughly 12 minutes late. I think that was worthwhile doing, though. And I want to thank everybody for attending, for making their comments today. Please do some homework, read the drafts while you're on the beach in August. And anything to add, Sarah?
When you read the drafts, the folks who write the drafts you'll have to read theirs, they'll read yours. So it's mutual both way. Please read.
Yeah, very good. Thanks, everybody. This was a great meeting. Great participation.
Is this not the coolest thing?